All right, welcome to Rebel Chat Reacts. Yeah, this is
Yeah.
our new reaction show where we react to funny YouTube videos on the internet.
Yeah. You missed the first 5 minutes, but
you then,
whatever.
once you do that, you establish the identity of who Christ is. And you can do that from that book. Once you realize who he is, he authenticates the package for you. That closes the loop. That's your epistemological cycle. And it's bulletproof.
He doesn't go on to substantiate this in this video.
Yeah, this is not substantiated in this video.
He does have like an hour's lecture on this, but it's not here.
Yeah, I do remember that. I do remember it. About like that's about the genealogy and shit. Yeah.
I mean, it's not just that.
It's the genealogy going for the arrow from establish the integrity of design to establish the identity of Jesus Christ is that's like genealogy and a lot of prophecies and et cetera, like a bunch of stuff like that. And then the authentication is Jesus calls back and quotes stuff.
Yeah. Jesus calls back and quotes stuff. That's the arrow going backwards. But the thing to be underlined here is the computational difficulty of making the gematria work out, the fancy number magic happening in the alphabet. For further reading, find the works of Dr. Ivan Panin.
On a sound epistemological footing. Well, so much for the introduction. That's where I come from. That's what dominates my orientation. But we're going to explore tonight a little bit about the myths of science. We're going to challenge specifically the myths of astronomy. Now, many of you know that one of my many hobbies, even as a kid, was astronomy. How many of you had astronomy in your background as a hobby or whatever? Many, okay, over half of you, sure. There was a time when I had money, a long time ago, I had a 14-inch Celestron. I mean, I was serious about it. If you go up to Big Bear, you'll see that domed house that has the, it was like, we took astronomy seriously. And I have to tell you, I'm startled to discover that most of what I've been taught in college, let alone in high school, isn't true. And that's what we want to look at. You realize we've had myths of the past. You know, way back they talk about the flat Earth, right?
Where is it?
I'm glad that we had the exact same idea.
I wanted to scroll down and highlight it. Where is it at?
I think your question or your comment algorithm is different than mine or something, because it's the first comment for me.
What the heck?
This guy goes, man, Chuck got a lot of things right, but unfortunately he was very wrong about the Earth being round. And then there's a bunch of other commenters just like rightfully shitting on that guy.
I only read the first like 5 words of that, but so I know that's gonna be funny. Anyways.
There was no excuse for that because Isaiah straightened that out long ago. But also, if you study the history of science, there's a phlogiston's theory about what burning really meant, and that's a bunch of foolishness. You go through the history books. And what we now know today is chemical oxidation. And then we had Ptolemy. We had the Ptolemaic cosmology, who believed that, which was a geocentric universe. Everything revolved around the sun. That was the Ptolemaic. Ptolemy, by the way, is an interesting character. He was eclipsed, of course, by Copernicus with his sun-centered cosmology. Ptolemy is going to go down through history as having opposed the two great truths of science. The fact that we have a sun-centered solar system is one of the things he failed to perceive. And the other thing was he proved in his own mind couldn't possibly be a fourth dimension. And that's a matter of record. It's kind of interesting. And he proved that the fourth dimension was impossible because he just couldn't visualize a four-dimensional orthogonal situation. And so higher dimensional geometry now is the ultimate source of unity in our present conceptions of the universe. So Ptolemy is going to have a very unusual place in history. But then there's this whole business of ether that they were trying to measure and so forth, and as a medium for light. And the Michelson-Morley experiment punctured that whole idea. That's dear to me, too, because you know where Michelson-Morley did that experiment? At the Naval Academy, of all places. So that's dear to us that we're Annapolis graduates. The velocity of light. You've had speakers here that is part of the fellowship of the Creative Science thing, Barry Setterfield, so forth, that I pointed out way back, Roma and Olaf Roma, under the days of Descartes, he had such prestige in the scientific community, and everybody believed, as he did, that the speed of light was infinite, and it was instantaneous. But it was Olaf Roma, an astronomer, by measuring the eclipses of the moons of Saturn, measured the speed of light, and at 300,000 meters per second. But the whole scientific community failed to accept that for 50 years. They just ignored his results until an Englishman by the name of Bradley did the same thing, repeated that experiment, and demonstrated that the speed of light had a measurable finite speed. And so that was a big revelation back then. Barry Setterfield, a member of the fellowship here, and Trevor Norman published over 30 years ago that the speed of light's been slowing down.
So I actually have this. I actually have these documents. I haven't read them yet.
Mm-hmm. I'm highly interested to follow up on this because this is one of those wacky things that Chisel Mizzle says that I would just really love it if that were true, because that would be that would go in the folder alongside the angular momentum argument from later on, that if it's true, it has staggering implications and it's a silver bullet. But will that happen? Haven't done the reading yet.
Yeah, I have a link to it. Here. It's called History of the Speed of Light Experiments by Barry Setterfield. It's on barrysetterfield.org, which is, I'm sure it's a very thoroughly researched one. I'm sure it's a totally unbiased source.
Yeah, well, it's probably an old website from back in the day when people had websites.
Oh, it is. It is literally text.
Yeah, what matters to me is not whether the guy has like bones to pick, but whether he's like correct in his estimations or not. Because a lot of this, if he's right, then I'm sure it's the kind of effect that you would have to see play out over the course of like decades. And I don't know about you, but I'm not going to check up on this again decades from now, probably, to see if that's true. So if somebody else has done the legwork on it, that's great. If as I suspect, this may turn out to be a total nothing, then oh well.
Mm-hmm. I mean, Tarbuck, how many times have you measured the speed of light?
Yeah, you do manage to like work yourself into a difficult sort of circular reasoning, because there are ways of measuring things that are cyclical, and there are ways of measuring things that are independently confirming.
What do you mean by that?
Okay, so when you try to like date rock or date fossils, you usually start one and get the other. But that is an Ouroboros. That is like, we know that it is this old because it's in this rock, and we know that it's in this, that the rock is this old because it has these fossils in it. That's cyclical, that's self-referential, that doesn't actually provide us demonstration.
Yeah. But for this, you're measuring the amount of time it takes for light to go from one spot to another.
Mm-hmm. And you would have to measure that in a way where the tolerances with which it is supposed to change is within your tolerances of measurement. And you would have to measure that in a way that is not cyclical. Like, we know that this object is this far away because we know what the speed of light is. We know that the speed of light has not changed because this object still looks that far away, etc. I'd want a different measurement. Anyway.
And I have dear friends that were among us here at Calvary that took me to dinner. Hugh Ross and his chairman, Alex Misler, happened to be old friends of mine, took me to dinner to patiently try to counsel me not to fall into the trap that the speed of light, everybody knows it's a constant, and they tried to counsel me not to get carried away with this foolishness that it was, slowing down. They took me to dinner, and I was very polite, but I chose to ignore them, and we published all of that in our journals, as you know, and of course, that has been vindicated in exciting ways. So the velocity of light thing, and I won't go through that whole story again, but basically, I got ahead of my slides here, so.
Barry Setterfield and Trevor Norman. The and Trevor Norman might prove useful. Anyway.
They'll be in the thing for what it's worth. The myths of the present time. Okay, those are past myths. In the present, we still live with the myth of evolution. When we say evolution, we don't mean evolution, we mean biogenesis. But the point is, that term is still taught in school. It's still the bedrock of our culture.
All right, zoom in on that. Okay, like, he has a way of like summarizing thoughts or ideas in an inflammatory way, and I'm really glad that he draws this distinction here between abiogenesis and natural selection. Because like natural selection is like one of the fundamental design forces that's like obviously tautologically true.
Yeah.
It must be this way for you to suppose any system. Whereas the introduction of new information into the genetic code of living things, that is contingently true. You have to actually go look at that.
Yeah, you have to find an example.
And normally he doesn't make this distinction. He just like hand waves over it, and just assumes that you know enough to know what he's talking about.
Yeah. Biogenesis is life naturally appeared due to natural forces and evolved to be more and more complex.
Yeah.
By him stating biogenesis didn't happen, he means that there was a God hand wave, and then like stuff was there.
When we say evolution, we don't mean evolution, we mean biogenesis. But the point is, that term is still taught in school. It's still the bedrock of our culture, even though it's provably false. And an increasing number of scientists have published clearly that it no longer is a viable explanation of our origins. And we're indebted to Michael Denton in 1986 and Philip Johnson and Michael Behe for they've published books in recent years that have put the evolution thing, turned it upside down. And these aren't Christians, they're just clear thinkers. And interesting. So the evolution thing is, to anyone that reads and understands, is foolishness, and yet it's still the bedrock of our culture. The velocity of light still being a constant is debated by many, and so forth. Let's take another thing.
By many, those two guys.
The nebular hypothesis. This is still taught in college today, okay? Because, what is it? A typical quote from Immanuel Kant, I'll quote, "Some 4 billion years ago, the sun had ejected a tail or filament of material that cooled and collected and thus formed the planets." Or some variation of that is what you will still find in astronomy textbooks, the solar origin of planets. Now, it turns out 21 years before Kant, this idea came.
So, the idea that the sun ejected some material and then that became the planets, that was not at all what I was taught. What I was taught is that there started a nebula which became an accretion disk, which most of which turned into the sun, and some of which just stayed where it was and settled out into the planets. Does that match what you were told?
Yep.
Okay. Just want to make sure we're on the same page there.
Yeah, it was just a huge disk of dust that formed from gravity. And then the center collapsed into a star, and the other parts collapsed into their own balls that formed into planets.
Yeah. Now, like, I do think that this next argument he's about to make is a silver bullet. Like, this is nuts.
From Emanuel Swedenborg, and he's quite a character, a mining engineer with quite a range of interests, and he also claimed to have psychic powers. And he came up with this nebular hypothesis idea from seances with men on Jupiter, Saturn, and places more distant. Does that give you some new confidence in Swedenborg? Don't laugh. There are people that take him very seriously. Some 20 years earlier, he had a chance to meet Edmund Halley, who was of Cambridge. He was famous for his predictions about the comet that bears his name. Well, he went to this with Immanuel Kant and Pierre Laplace, who was a famous mathematician. He lent his endorsement to Kant's theory. He got from.
What I'm trying to remember, that's Laplace.
Laplace's demon. It's the guy who conjected that thing, which is it's a model of thermodynamics to show it's a lot to get into. It's beyond the scope of this video, certainly.
Beyond the scope of this video.
Yeah, like I don't want to spend like the next 20 minutes talking about thermodynamics in order to like just explain who Laplace was. He's a mathematician and a physicist. Let's leave it at that.
I just thought that Laplace was used as a name in some. I think
it's the name of the. It's the name of the black demon from the Slimy Sky.
It's also the name of a fleet in Legend of Galactic Heroes, I think.
The Japanese love Laplace's demon. They love it.
Yeah, no, I definitely heard that name in Legend of Galactic Heroes, but I can't remember from what.
From Swedenborg, but he did it without checking the mathematics. He had the math background to puncture this. He didn't bother to do that. So the nebular hypothesis gained widespread respectability despite its mathematical flaws. Subsequent writers have continued about variations of the view even though increasing difficulties renders it very doubtful. What am I talking about? We know that the sun contains 99.86% of all the mass in the solar system. Think about that. The sun is virtually most of the mass of what we call the solar system, almost all of it. Yet the sun contains less than 2% of the angular momentum. The 9 planets contain 98% of the angular momentum. What's that got to do with anything? It simply means that the planets couldn't have come out of the sun and cooled. And this was known, by the way, at the time of Laplace a century ago. There's no plausible explanation that would support a solar origin of the planets. You can try to formulate one. It doesn't work. It has any mathematical integrity. Now, it gets worse. James Jeans, point out
All
that
right,
the outer
pause
planets are
that.
far larger than the inner ones. That's
So that is, by itself is one of those silver bullets that I always look for. Like
Yeah.
to think about this very, very generally for anybody who doesn't know what the fuck we're talking about. Get on a rolly office chair and spin around with your arms and legs flung out as far as possible, then pull them inwards. Your speed will increase by a lot because the rotation speed or the rotational force of your limbs is preserved, and then when you bring it inwards, spinning the same amount of spin is happening over a smaller space, so you spin faster. The spinning has to be conserved, and this would be true of any spinning object anywhere. So if you start out with a big spinny cloud of gas and then you turn that into a star, that star had better be spinning at like in just a completely bonkers rate.
It should be spinning at near
order-
light speed.
Yeah. Now
I think I did the math, and I was like, if you were to throw the planets down into the sun and conserve angular momentum, I think it would be like 23% speed of light.
that is crazy.
Yeah, on the surface, you know.
Yeah. Now trying to get the planets into the sun while preserving their rotational speed would be really damn hard.
You
But,
couldn't.
You couldn't do it because of the like the relativistic problems of it, and the
You would have to
there's
slow
lots of
them
things that are
down so that
difficult about
gravity
moving a
pulls them in.
planet. Yeah. I did the other math of like, all right, well, let's not just believe him. Let's check NASA's published numbers about the rotation speed and the orbital speed of the planets, and like reconcile those together using like, you don't need much more than like a high school level physics for this, assuming you took physics in high school.
Mm-hmm.
Like it's really basic mechanics, but like the proportions that he's talking about, like the magnitudes are just way off from each other. So if anybody like thinks that this is sus, I encourage them to do it themselves. And are you smarter than a fifth grader your way into believing some wild shit?
Yeah, this is something that I want to like. I often have the experience of I have a question, and I'm like I have a prompt like this, and then I try to figure it out, and then I think I do. I think I have it figured out, but I wonder like, okay, if I were to go to like an astronomy professor at like a decent college, and I go like, hey, here's this problem. What is the solution to it? Because either A, like the angular momentum of the planets and the angular momentum of the sun can be totally divorced, or they cannot, in which case you need to like question a lot of things.
Yeah.
And like,
I really like the convenience of the argument where like this should be the kind of problem that just stares you in the face the whole time, but you have to think to ask it in the first place.
Yeah.
And you wouldn't necessarily.
It's very hard to explain. Jupiter is almost 6,000 times as massive as Mercury, almost 3,000 times as massive as Mars, and those are problems if you try to make a model for that to have happened somehow. So this is a difficult recurrent theory. So there's other enigmas. As we study the planets, we discover they apparently are in pairs. The rapid spin rates among the planets are within 3% by pairs. And as you look at this, the Earth and Mars, Jupiter and Saturn, and Neptune and Uranus are within 3%. Why? Why are they paired in their spin?
Something
This one I didn't even encounter.
This right here is a liner centric slide, and I'll leave it at that.
I really hope some of this is in command line.
This slide right here isn't in command line. It's in it goes all the way back. This shit is in Psywars. Because if you'll notice, Mercury and Venus are not on here. which is also true in Sci Wars. Like Mercury and Venus aren't paired like the rest of the planets are. So I went, delete. Just deleted 2 planets for the cosmology of a fictional universe. Because I was like, oh, they're not paired? Gone. So there you go. That's for Psy if they ever watch this video.
Spin rates, nobody knows. Earth and Mars have a virtually identical spin axis and the same tilts, 23.5 degrees. Why? Nobody knows. From the angular momentum, pairs of these planets that may have been brought, it appears that they were.
The similar axial tilts of the 2 planets, that's really cool.
Yeah, but not all of them are similar. That's the thing that was really weird to me is like, okay, why do some planets spin like this? Why do some planets spin like this? Why is everything not on the same plane?
Why does one of them spin backwards? Why does one of them spin sideways?
If it's due to like a giant meteor collision or something, then like wouldn't that cause it to like spin way off axis?
Mm-hmm. Well, not just that, but like you would have to. Actually, I can't say this with confidence because I haven't done like rotation and impact in 3 dimensions, but it seems to me like hitting an object, even one that's already spinning, off center that sends the poles tumbling should keep the poles tumbling. You know what I mean?
Yeah. Well, okay. So something I know about that is that there's a experiment you can do with like a bicycle tire, where if you have a bicycle tire and you're spinning it, right, it has its own momentum and acts like a gyroscope. And then if you push down on, like, if you spin it up and then you push down on one side of the bicycle tire, it won't want to go down there, but it will go down 1/4 of the way forward in its spin, because you're changing its angle there, but then it ends up going down, and then it has to push the rest of it up to counteract it.
Okay.
Yeah, like, you can force the part you're pushing on down, but the part 1/4 of a turn ahead of it will go down twice as fast, or it will want to.
Okay. So that would be how you would get a rotating body to change axis.
Yeah, without necessarily tumbling, maybe.
Yeah. Tumbling like a pulsar, that is.
Yeah.
Were brought here from somewhere else. I'm speaking just in terms of secular conjecture so far. You follow me? Why does Mars have 93% of its craters in one hemisphere? The craters on Mars, 93% are in one half of the thing, and there's only 7% in the other half. In fact, as they studied it, it would appear that 80% of those craters occurred within the same half hour. Why? Nobody knows. But these are unexplored aspects to their origins.
Please source that. I really want him to source that. Do you remember if he does in one of his other talks?
I haven't.
If we don't find this in like 2 minutes, then I'm going to say that it's an exercise for the reader.
There's an 80%.
Because we're not
right
even
here.
at the wild shit yet.
Yeah. There's an 80% right here. 80% of Earth's surface is less than 200 million years old, while 99% of the Moon's surface is more than 3 billion years old. That's an interesting one. We're looking at Mars.
There's there's something in the Moon surface about like how deep does the layer of dust and craters go, and does that match our predictions for how old the Moon is? I don't remember the full substantiation, but like, there's another Chuck Misler video about that.
The Quora.
Quora is Reddit for people who teach college instead of attend it. You got anything?
I don't think so.
Oh well, too hard to find. We'll work on that later.
But these are unexplored aspects of their origins. This gets to some other conjectures that you've all heard about, the idea of dark matter. The quote that you see in many articles, dark matter makes up about 26% of the universe. Really? The first hint of its existence came in 1933 when the astronomical observations and calculations of gravitational effects revealed that there must be more stuff present in the universe than telescopes could see. That's a widely held belief of many of our top scientists today. Why? I'll show you why in a minute. There's also dark energy. Dark energy makes up approximately 70% of the universe and appears to be associated with the vacuum in space. Well, there's no vacuum in space. That's a whole other thing we'll get into. It is homogeneously distributed throughout the universe, not only in space, but also in time. In other words, associated with the vacuum in space. Well, there's no vacuum in space. That's a whole
There is no vacuum in space is... Okay, there's a couple of different ways that you could interpret this. One of them is the interstellar medium of like diffuse hydrogen gas. There's like the tremble, the seethe of quark anti-quark pairs at the bottom scale of the universe. What the virtual particles you might call oblivions. There's the 0-point energy. There's like the various fields, like the Higgs field, the electrical field, the etc., which do fill space, but technically, like not in the way that we normally think of filling things.
Yeah, they do not have mass.
There's the vacuum of space having properties like electrical impedance. There's other stuff tied up in this idea of the empty space having substance.
Mm-hmm.
And he doesn't at all clarify which of those he means at this time.
Another thing we'll get into. It is homogeneously distributed throughout the universe, not only in space, but also in time. In other words, the effect is not diluted as the universe expands. Really? These things are non sequiturs, and yet they're widely held among scientists. In fact, you should stand back, and it's humbling to realize that all that we know about matter comes from a 4% sample. There are books that tell you 96% of the mass of the universe is missing. How many have heard that somewhere? That's ridiculous, of course, it turns out. Okay. And most of you are familiar that they're chasing some of these things with big dollars. The Large Hadron Collider in CERN in Europe. It spans the border between Switzerland and France near Geneva. It's 300 feet underground. It's the largest machine in the world, a circumference of 17 miles. It's the fastest racetrack in the world. Trillions of protons traveling at almost the speed of light, guided by 9,300 magnets. We spent a lot of money here. 600 million collisions each second. And we could go on and on about this thing. There's also a project we're going to talk about a little bit called the GEO 600. This is an attempt in Europe
All right,
to
hang
measure...
on a sec. Okay, so going back a little bit to that, like harping on dark matter and dark energy, etc., and the ratio of like mass to observed mass to invisible mass. What I really would have liked it if Chakaru Mankai across the 8th dimension here was like around for a theory that got like press like maybe 4 months ago now, about how if you view gravity as an emergent property of space rather than as a fundamental force, like if you eliminate it from the list of fundamental forces and consider it to be a property of space rather than a property had by matter, a lot of these problems go away. Like we now have models of the universe that are at least getting talked about that just have a different view of gravity that cascades up in scale differently to make galaxies hold together just fine without the need of dark matter. But I don't know if that, like, because that's so new. I don't know if the math checks out on that. I don't know if that, like I've seen previous attempts at this back in like 2004 when somebody was suggesting that force equals mass times acceleration is not perfectly continuous, that it like bottoms out somewhere, that at a low enough application of force by distant fields that it asymptotes to a very low but constant thing that would make galaxies hold together. Which of these things, and that one I heard once and then never again, because presumably it got disproven. I didn't hear the chatter around that, but other people have tried at eliminating dark matter before, but dark matter obviously looks like a phlogiston theory. Phlogiston is something that Chucky Boy here talked about earlier in the presentation, which is just a placeholder substance to explain a phenomena that we don't know the explanation of yet. And it just seems to me like with ether, like with phlogiston or phlogiston, if you're from Britain, then it's clearly a placeholder for things we don't know.
Yeah. I mean, we don't know anything about it. We haven't observed dark matter.
Well, it's not just that we haven't observed dark matter. It's like if Laplace published Laplace's demon, and then people took the model seriously and thought that there were actual demons doing thermodynamics. That's what dark matter is like.
Yeah, basically. There's a really interesting part of Red Dead Redemption 2 where you can walk up to an NPC, and there's a lot of really interesting, because it takes place in 1899. There's a lot of weirdo scientists who will interact with your character, who is very much an everyman from 1899. One of them is like, "Oh, hey, I've invented a radio powered boat. Not radio powered, but radio controlled boat." He's got and everyone's like, "What the fuck? This is total wizard shit." But then a lady will be digging up dinosaur bones, and everyone's like, "Yeah, everyone knows about dinosaur bones." And then she's like, "Do you know they were all extinct?" And they're like, "What? Why are they all dead? That's stupid. There's probably still some around."
Which, you and I have talked about that one separately.
It's just funny to think that they exist in a world where they can't imagine things being any different.
Yeah.
To the extent of your character will look at a T-Rex skeleton and be like, "Whoa, that must be pretty crazy." And then someone's like, "Oh, it lived 500 million years ago." And then they're like, "What?" And they just don't know how to deal with it as info.
Yeah. I mean, a lot of people today can't really conceive of what if we kill all of something, even though we've done it many times.
Yeah.
Try to find and measure gravity waves. And the pursuit is of relativistic gravitational fields implies the existence of particles called gravitons. These are particles that have never been seen that they're going to try to find, okay? Massless, uncharged particles moving at the speed of light, but so far undetected. Now, kind of interesting sidelight here, in making this project, they discovered that there's some
gravity waves and gravitons aren't exactly the same thing, but whatever.
Yeah. I'll say that I personally think, for what that's worth, that gravity is a property of space and curvature, but that's a whole other thing.
And in Europe, the head of Fermilab wrote them a letter suggesting that noise might be due to the granularity, due to the fact that the universe is a hologram. And that's caused a whole stir. That discovery may be more important than the gravitons they were trying to find. And there are experiments going to be conducted this summer to try to confirm that. David Bohm, a confederate of Einstein, said he was a guy that happens to have...
That's been confirmed, by the way.
Yeah. No, we know that we live in a digital universe.
Yeah, not just in a digital universe, but also that what we experience is... all right. For further reading, look up the bulk and the boundary.
Oh, yeah.
Just like the thermodynamics thing, I'm not getting into it here. No, don't actually. I just mean the bulk and the boundary is how you think of this thing. Because you can't destroy information, how do you encode three-dimensional information onto the two-dimensional surface of a black hole? It's something like that, but the image produced is the universe as we experience it, and not the outer world.
His background was in plasma physics. He was fascinated with plasmas. We're going to talk about that tonight. But he came to the conjecture that the universe may be a super hologram. That's why this GEO discovery is so exciting, because it reopens that whole discussion. And so the GE600 is a gravitational wave detector located in Sovjet, Germany, and so forth. We have to go into all this stuff. Well, I'll give you some feeling about the money they're spending. It's designed to detect relative changes in distance, the order of 10 to the minus 21 centimeters, about the size of a single atom compared to the distance from the sun to the Earth. That's accuracy. That's what they're struggling with. And so we'll see what happens anyway. I don't want to spend too much time on gravity waves other than they were predicted by Albert Einstein, but never been actually observed. And that's what the GE600 is chasing. Okay, enough of all of this. Let's zero right in on the myths of the present. One of the statements that you see is there is a black hole in the center of that galaxy. Why do they say that? Well, if there wasn't, they can't explain its level of energy output. That's a conjecture to try to explain something they can't explain. There is invisible dark matter in that galaxy. Why do they say that? Because otherwise, they cannot explain why it rotates the way it does. The way the galaxies rotate imply that there's not enough mass there to cause that to happen gravitationally, so there must be mass that we can't see. That's why they call it dark matter. Okay. Another statement you see in the current, I'm talking about current reports in your literature. 96% of the universe is made up of dark energy and dark matter that we cannot see. Really? That all we know about mass comes from a 4% sample? You gotta be kidding. Otherwise, clusters of galaxies would fly apart because gravity alone can't hold them together. Really? Then maybe something other than gravity is operative here. Pulsars are made up of strange matter. That's another statement you see if you start reading in pulsars. Otherwise, they can't explain their oscillator type of behavior.
When he says something other than gravity might be holding galaxies together, and you know who this guy is, what does that make you think?
Oh, I feel like I know what he means. He's saying that Jesus is holding the galaxies together. Just like the firmament, dude. Just like the firmament, dude.
He gets into the firmament in a little bit. I just like where this whole argument terminates is why we're watching this video.
Behavior. But here's the fun one. Photographs of connections between two astronomical objects that have different redshifts are only chance alignments.
Anyways.
Redshifts are supposed to be measuring the expansion of the universe. They have some things
that one's a wild one. Do you want to try to unpack that? Do you want to try and unpack that one?
But here's the fun one. Photographs of connections between two astronomical objects that have different redshifts are only chance alignments.
He's like kind of cutting it off, which is hard. Photographs of connections between have different redshifts are only chance alignment.
Yeah, the thing that he's claiming
is that
here
like
is that there are objects...
Is that like shadows kissing? You know what shadow kissing is?
The claim is that there are that when you see two objects that are like interacting gravitationally, or there's shared like a shared stream of plasma between them or something like that, that is actually, like, the claim is that that's an optical illusion because that they have different redshifts. But what he's implying here is that we can see from other stuff about them that they are physically close and gravitationally interacting with one another. But if they had different redshifts, then that doesn't make any sense.
Yeah.
Because that means that they would be going at radically different speeds.
Yeah, like, I mean, couldn't that mean that they're just orbiting each other? But I guess that means they have to be orbiting each other like really fast.
Well, they couldn't be orbiting each other conventionally. Because if they were orbiting each other, then one of them would have to be going a lot faster than the other, which doesn't make for a stable orbit. I guess you could have one that's really, really, really big and one that's only kind of big, like an apple on a basketball. But if that's the case, then we would see the redshift on one of the stars oscillate.
I was thinking just that they're equivalent size, but they're both just orbiting really quickly around each other.
Right, but the redshifting effect is supposed to come from the Doppler effect. It is their motion relative to us. So if they're orbiting each other that way,
they're redshifted.
Then they should have to have the same redshift as each other.
that wouldn't necessarily be the case. If they're in a rotation where one of them is coming towards us and one of them is going away from us, even if overall they are moving away from us or towards us, that would produce
Well,
different shift.
Well, for how long then? Because we have been able to track objects like these over decades.
Yeah, it depends on how long, depends on how long. I'm imagining 2 stars, even if 2 stars are going really, really fast, stars are fucking huge. So, they might be able to have a redshift, have different redshifts, or be going in a speed where redshift matters, and be in orbit, but still take hundreds of years to complete a rotation or something.
Well, in order to have a noticeably different redshift, they have to have the difference in speed has to be enormous. It has to be percentage wise, like a pretty significant chunk difference relative to the speed of light.
Yeah.
Like a 1 or 2% difference from each other. Which I don't think an orbit like that is realistically possible.
Yeah, but we're also extending this from a 9-word sentence without punctuation, by the way.
Yeah.
So, I'd have to look at the case that he is presumably talking about that presumably exists.
Redshifts are supposed to be measuring the.
Also, that's just my first thought of oh, why would that be happening? Maybe this. I don't know. Depends on what the details are, but whatever, it doesn't supremely matter.
Expansion of the universe, they have some things that are so close together, they're apparently associated, and yet they have different redshifts. That's embarrassing. Now, how do they explain that? See, if they're only chance alignments, otherwise the Big Bang is being falsified, the whole Big Bang theory. Halton Arp was Edwin Hubble's assistant, a long-time observer at Mount Palomar and also Mount Wilson. His photographs contradict the whole concept of the Big Bang. And so he's not allowed to publish in most of the technical journals because they don't agree with his obvious conclusions. I'm reminded irresistibly of a passage in Lewis Carroll's story about Alice through the Looking Glass. You probably remember that from your childhood days. Alice, the White Queen in the story, says Alice says, "One can't believe impossible things." Alice laughed. The Queen says, "I dare say you haven't had much practice," said the Queen. "When I was your age, I always did it for half an hour a day. Why, sometimes I believed as many as 6 impossible things before breakfast." Now, this is Charles Dodson, otherwise known as Lewis Carroll, his way of poking fun at the irrationality there. But how interesting it is, that's exactly what's going on in our so-called scientific fields. They're forced to accept things they know can't be possible. So I want to talk a little bit, before I go further, on what I call epistemology 101. Epistemology, study of the origin, scope, and limits of knowledge. We take pride in a methodology we call the scientific method. How many have heard of the scientific method? The other name for that, more properly, is called the empirical method. What is the scientific method? If I give you a written quiz, I imagine a few of you could pass, because here's what that really means. Step 1, you observe a phenomenon. Step 2, you seek patterns and measures in that observation. Step 3, you formulate a hypothesis from that description. And then the 4th step is you gather independent data to challenge that hypothesis. It's that simple, and yet it'll shock you to discover that it's rarely practiced in certain fields of science because they can't repeat the experiments that they're trying to explore. See, the search in scientific method is a search for failures, not successes. Theories can never be proven. Did you know that? That comes as a shock unless you studied this field.
Mm-hmm.
So that's like the 4th different recounting of the scientific method that differs from all of the other ways of explaining the scientific method. And the pithy quote, "Sometimes science is more art than science," is or rather, there's messiness in methodology. That is true. The fact that any version of the scientific method is rarely actually how science gets done, is true, but nobody likes to talk about it. I'm not going anywhere with this. I'm just saying that this is a thing that does happen, and if you talk to scientists who do lab research, they will tell you this pretty directly.
Yeah, I mean, they're just usually looking for either a particular result or the results of a particular test. I think about like gene things. It's just like, okay, we're trying to find out a way to like swap these genes out of this cell with like CERN, with like not CERN, whatever it's called. And they just do it. They just do like 200 trials, and then they're like, oh, all of our trials didn't work. Well, shit.
Mm-hmm.
And then
Yeah.
someone else does it, and it's like, well, we did it, and we got 3 to work. Like, oh, we did it 1,000 times, we got 3 to work, and like.
And an aspect of this whole thing that isn't really commonly explored is that a lot of times the science is done back to front. You think of a question that you want answered, and then you try to do a bunch of stuff to figure out that. And then when you get your data back, usually you ask the wrong question. And so you try to interpret the data in a way that would try to tell you what the right question to have asked was, and then you try to get grant funding for that question.
Mm-hmm.
Yeah, that's anyway. We can keep going.
Yeah. Also, with regard to people believing things because they were that they didn't prove to themselves, it's like, well, yeah. I mean, you don't want every. Do you want every science student to have to independently verify all of science by themselves?
Right. This is the division of intellectual labor.
Yeah. It's just unrealistic to have that happen for everyone, and because it doesn't happen for everyone, no one does it.
Mm-hmm.
Like, it is very rare that people go back over, and like put serious effort into going back over things that are taken for granted.
Oftentimes to the detriment of the field that they're in. Like, there's a bunch of stuff in psychology that I could name that I won't go into here because it would be a very long conversation.
There is so much about that in computers, where people have just been doing computers for just building on building on building, and it's a total mess. And literally everyone knows it's a total mess now. I think that's the same kind of thing.
Yeah, but if you tried to go back and fix it, or like start from scratch and do it right, it would be so much work to get back to where we got that.
Yeah,
nobody wants to do it.
Exactly. It works well enough, even though it only works like 80% of the time.
Yeah.
Study that theories can never be totally proven. What they can do is defy being disproven, but they're never fully proven. They develop a reputation for being difficult to disprove. There's a big difference there, a profound difference there. When you study information sciences, Shannon calls what he calls verifiability, the definition of meaning. Something that can't be verified is defined in information sciences as meaningless. If you can't verify it, it's a meaningless statement. For example, if I suggested to you that before this talk is over, all clocks in the world are going to slow down by 10 seconds. Well, if all clocks in the world slow down by 10 seconds, there's no way to prove that. That's what we call a non-verifiable statement, which means it's meaningless. See, it only has meaning to the extent it can be verified. Untestable statements are defined as meaningless. We need to grasp that. It's important. The great tragedy, according to Huxley, the great tragedy of science is the slaying of a beautiful hypothesis by an ugly fact. Non-falsifiable hypotheses are non-scientific, and by the way, they're intellectually dishonest. And yet we'll discover our lives are full of those. In logic, there's a classic error in logic. It's called argumentum ad ignoration, and it's an argument from ignorance. The assertion that something must be true simply because it hasn't proved false is an error in logic. Just because it hasn't been proved false doesn't make it true. You need to understand that. It's fundamental.
It's an error in a kind of logic.
Well, since the scientific method is really not available in certain fields of science, archaeology, geology, there's no places where you're studying something you can't get a repeatable type of situation, so you go to alternatives. What are the inadequate substitutes for the scientific method? The first is the deductive method. That's where you derive theories by generalizations about the universe. They may be useful, but they're not necessarily true because they haven't been verified.
Kind of.
Another alternative, and this is the one that we've all been injured by, mathematical proofs. Elegant consistencies that occur within a synthetic universe. And mathematics is a synthetic universe. Mathematics is a collection of symbols and rules that create a synthetic universe. It doesn't necessarily bear relevance to reality. That may shock you. Elegant consistencies within a synthetic universe, models are not reality, no matter how elegant they are. You've got guys like Stephen Hawking and a number of these other.
I'm not going to go into all of this in this moment, but I'm going to be calling back to this. So I want this section where he talks about the inadequate substitutes for verifiability. I want this to be well remembered. Because, that's that is not how I would explain the deductive method whatsoever. B, this, like, his use of synthetic here is not technically correct, which is weird because I know he's a technical guy. He was an engineer before he got into God. But sure, models are not reality. However, like, I just want you to remember that he is arguing against mathematical models right here, or like not in the full way that somebody could argue against modeling, but just even that he is doing this much, it'll be relevant.
All right.
Mathematicians, they're absolutely brilliant. And they explore and dive into subtleties of these incredibly elegant, complex mathematical models. That doesn't make them correct. It doesn't mean they have anything to do with reality that is yet to be demonstrated. And so there's another source of error. That's even equations that prove to be correct may be correct only within certain domains of validity. What you know about the weak and strong nuclear forces have nothing to do with gravity. They're true with what happens within the atom at very small distances. What happens in gravity is quite different. Well, we're going to see quite different what happens in the galaxies. I'm going to demonstrate that to you in a minute. Okay. Now here's probably the most disturbing one of all. When all these other things fail, if you're a scientist, your next challenge is to get your thesis, your paper published in a journal, what we call a peer-reviewed journal. And the process that occurs, it sounds pretty good at first. You have people that are your peers make comments on your paper. But think that through. That whole process has a tendency to ossify the field of study. Because if your paper challenges the common understanding, you won't get published. You see, you're having to have your competitors control the gateway to truth. So why are we surprised that science, especially as science starts to involve larger and larger sums of money, it gets harder and harder to get that money because it's controlled by people who have a vested interest in the status quo. So it turns out that these methods all are very frail and do not necessarily lead you to truth. So I want you to realize that inference is not proof.
Now, that I think is his best one.
Mm-hmm.
Like, calling out the publication, like everything to do with publishing any of your ideas is, like, he's spot on with that one.
Yeah.
There's a lot of, like, perverse incentives in the publishing of science as an industry, and that does really bad stuff to the fields of science that we're trying to like explore. Generally, like, the reproducibility problem is largely the result of this kind of tampering.
Yeah. No, I think it should be no secret that peer-reviewed journals are not a good solution. There needs to be a different system.
And we were overdue for a different system a long time ago. And
in the Enlightenment.
Yeah. Like, that as a social barrier to the learned public is such a force that holds back so many aspects of knowledge. Like, any random person online will tell you to read the papers, but what you're actually doing when you read most of these things is reading the abstracts, because the papers cost $5 to $20 a piece. If you wanted to read all of the literature and you don't work for a university with a subscription to one of these journals, you just can't. You can't afford it.
Yeah, it's ridiculous. And, like, fuck the journal. That should be free.
Yeah, we shouldn't be producing like privatized, paid gatekeeping on knowledge that was paid for with public funding.
Mm-hmm.
Fine, that's an inference. Doesn't mean it's been proven. The other thing you want to guard against is avoiding the logical fallacy of asserting the consequent. What do I mean by that? If A, then B. If B is true, then A must be true. For example, if it is raining, the street is wet. Well, the street is wet, therefore it must be raining. Not necessarily. This ignores the possibility of an alternative. The street cleaning machine may have just gone through. I meant to see that asserting the consequent is a common failure of logic. If you're not watching for it, we all do it, and it's wrong. The illusion of knowledge, the only one certain barrier to truth, is the conviction that you already have it. You know, our trademark Bible verse for over 40 years has been Acts 17:11. To be like the Bereans, in that they receive the word of God with all readiness of mind, but search the scriptures daily to prove whether those things be so. The difficult part of that policy isn't searching the scriptures daily. The difficult part is having an open mind. Because we're all victims of our presuppositions. We need to guard against that, and we recognize that. Fortunately, the greatest obstacle to discovery is not ignorance; it's the illusion of knowledge. The belief you already have the truth.
I love that he goes directly from the barrier to knowledge is the belief that you already have it, directly into a Bible quote. Like if you don't think the things that he thinks are true, that is the funniest shit possible.
Yeah, because a lot of people, they do that as jumping to the exact opposite.
Yeah. Oh man,
shit! I dropped my microphone. It just worked. It worked off.
Oh no,
That's fine.
Aww.
I wasn't the one I was using. It will now live over there.
Truth.
Okay.
The Lord has been echoing in my mind. This goes my life. I go back. I can mention several. Been echoing in my mind for reasons I couldn't explain. A phrase. I don't know where he gave it to me.
Oh,
I woke
yeah.
up one morning.
Tiny thing.
What?
Tiny thing. In my education, rather than asserting the consequent, I heard that as affirming the consequent. I think that's a little bit better of a technical term for the logical fallacy that I was talking about before.
Okay.
Just a little bit of cleanup.
Metaphors reign, where mysteries reside. And that bothered me. What does that mean? I've been chewing on that for over a year now. Metaphors reign. See, when we don't really understand something, we give it a fancy name to hide the fact that we really don't understand it. That's part of what's going on here. I want to contrast science with technology. Most of us use those terms as equivalencies.
We're on another command line slide here.
Yeah. Immaculate.
What's the difference between science and technology? There's a very important difference. By the way, something else I just mentioned as I grow in the word, I'm convinced there are no synonyms. I think two words can be synonymous in that they mean almost the same thing. But watch out for that word almost. When Matthew uses the term kingdom of heaven, and Mark, Luke, and John use kingdom of God, 99 out of 100 commentators say, well, those are synonymous. No. Because the kingdom of heaven is a genitive of source, not a genitive of opposition. And Matthew's being more precise. And out of that comes a whole discovery. Because he uses that term 33 times, but 5 times he used kingdom of God, which proves that they're not synonymous. So the point is, watch out for the so-called synonyms. There are treasures there. Well, science and technology, we tend to use synonymously. No. Technology produces useful products.
Hold on. It doesn't prove that they're not synonymous. It suggests that they're not synonymous.
Mm-hmm. Careful, Chucky.
Technology produces useful products. That's why we have computers and pacemakers and thousands of appliances, information appliances, and all kinds of appliances in our lives, because they're useful. That's technology. Science has become a religion with its own priesthood, and we need to be on the guard of that, because it's a subject of presuppositions, myths, and so forth. Now, let's talk a little bit of the milestones of influence. Johannes Kepler, in the 16th century, he discovered that planets are in elliptical orbits with sun at one of the foci, that the sun's radius vector sweeps equal areas in equal times, and that the planets' squares of the periods are to each other the cubes of their mean distances. Now, that, in his day, was a profound advance in understanding that explained.
Okay, 1, got it. 2. Two, I think I get. 3, I don't get it. 3, I don't know at all.
I think that has to do with how you mathematically model an ellipse. Like, if you remember the equation for an ellipse, there's squares in there, and there's a difference of degree in the motion of the thing. I think that's what that means. I don't remember if it's linear to square or square to cube. All right, that's all quadratic. All right, there's that difference of there's a difference in squares there. All right, I was wrong. Oh, periods. It has to do with frequency.
Yeah. I got that part. I saw planets squares, and I was like, wait. They're round. I think
Square of the period. Yeah.
hang on.
the motions
Mathematics
of
of
the solar
frequency
system.
is a
And that was,
place where I'm not really good at.
and it was within a decade later that another guy was born by the name of Sir Isaac Newton. And he carried that principle of Kepler substantially. He established the basis of classical mechanics, advances in optics, differential and integral calculus. And he was a serious Christian, by the way. That's the other thing interesting about these early founders. You may not know that Sir Isaac Newton wrote over a million words on Daniel and Revelation. I have the copy. This is interesting reading. He wrote on hermeneutics. But he's most well known, and he changed the world with his what's known as the inverse law of universal gravitation. And I want to talk about this because this one contribution of his changed the whole scientific landscape. And the inverse square law of the theory of universal gravitation. And what most astronomers fail to do is recognize the inverse square law aspect of that. This was his equation, that the gravitational force is equal to a constant having to do with units. It's the product of the masses divided by the square of the distance between them. And we'll talk a little bit more about G. It's not that important for us here. But I want you to remember this d squared underneath. In other words, you take the product of the two masses that are being attracted, and you divide by the square of the distance between them. That gives you Newton's law of gravitation. The whole field of astronomy is obsessed with gravity. But they fail to really understand that d squared thing. I'll show you what I mean by that. Well, after Newton, we run into a guy named Ben Franklin, 1706 to 1790. And while he did many things in his life for our purposes tonight, there's one event had. The amazing thing was he wasn't electrocuted. He was stupid enough to fly a kite during a lightning storm. And he risked electrocution, but he determined that the sky was inherently electrical in nature. And the entire scientific community chose to ignore that. It's amazing that it took several centuries for that to be realized in the scientific community. It's still just being recognized by the astronomers. I'll show you what it means as we go. After Ben Franklin, we have a guy by Michael Faraday, 1791 to 1867. He's the one that pioneered the concept of electromagnetic fields. In fact, Albert Einstein kept a photograph of it.
The sky is electrical in nature is just being reckoned with by our modern astronomers is a hell of a claim. I know what he means, but he's being ambiguous there. Perhaps on purpose for the sake of being evocative, but it leads to an interpretation of his words that is just like totally wacko disconnected from reality if you read him the other way, which is that people don't know that the atmospheric sky is electrical.
Yeah.
That's a really messy way of delivering that note.
When it just the atmosphere protects us from electromagnetic radiation.
Hmm.
We exist inside a
he
giant
means
compass.
more than that, but let's.
But yeah,
On the study of
I figured it either didn't matter, or he's being poetic about something. He was just being poetic about something. I ignored it.
study wall.
It's the third option, which is the funniest.
James Clerk Maxwell. Faraday was highly religious. Here's another Christian. Member of the Christian sect that demanded total faith and commitment. And even the biographer said he had a strong sense of unity of God and nature pervaded in his life and work. Well, I hope they say that about all of us in our epitaph, if you will. Now we come to a guy that we're going to talk a little bit about tonight, because he's ignored by most people who get into, unless you either ignore him or you really get into him. Very few people in the middle. A guy named James Clerk Maxwell. He codified the basis of all that we know about electrical science and engineering into a self-consistent set of equations. Originally 20, finally boiled down to 4, but all about electric currents and magnetic fields, that they intrinsically are connected. That magnetic fields, electric currents and magnetic fields are intrinsically involve common behavior. And that electromagnetic energy propagates through space. So far, so good. Thank you, Sir Isaac Newton and Albert Einstein, and the fundamental nature of his contributions in quantum theory, electromagnetics and electrostatics, thermodynamics, information theory, and quite a guy, by the way. Okay? But along comes a guy by the name of William Thomson, who gets knighted, and he's known as Lord Kelvin. And from 1824 to the turn of the century, to 1907, he becomes an incredibly influential scientist in 1900 Great Britain. Lord Kelvin, profound influence. He was knighted for his work in thermodynamics. That's the good news. Let me give you the bad news. He was an outspoken critic and very pessimistic about the future of electricity and electromagnetic theory. He predicted that radio and wireless telegraphy had no future. Now, we laugh at that today, but he cast a pallor on that as far as the British scientific community is concerned. And as you study history of science, you'll discover that from Kelvin on, the British Astronomical Society goes one way, and a whole other field of study is ignored by them that comes out of Norway, Sweden, and the northern latitudes. And that's what we're going to focus on tonight. But Kelvin was a cloud on this whole picture. And so I want you just to recognize the negative influence of this one man. Now, before we go any further, you need to have something else that I want you to do. I want us tonight, we want to have a way to somehow relate to extreme magnitudes. Scientists use fancy numbers to represent large magnitudes, but often they don't really understand that. I remember I was with Edward Teller and his sidekick, Norris Keeler, and they were talking about 10 to the 17th something or other, and I said, gee, that's more than there are seconds in the history of the universe. They looked at me startled. What do you mean? Well, you're the guys who are going to try to tell me that the universe is about 15 billion years old. That's only 10 to the 17 seconds. They were startled. Let's do the math. See, they use those numbers, but they didn't really have an appreciation of the science. We need to have an apprehension. Let me give you a new word that's in our vocabulary today to demonstrate what I'm talking about. We have a new word called trillion. How much is a trillion? I have yet to find a congressman or senator that can answer that question. I'm serious. How much is a trillion? Okay. My old friend Bill Ruggles is here, and he and I got into some strange investments years ago. And if I said to Bill, I know I owe you some money, but I'm going to pay you back in 1,000,000 seconds. Bill would take out his calculator and a million seconds. Well, that's 12 days. I can live with that. Oh, I'm sorry, Bill. I misspoke. I'm going to pay you. A million seconds. That's 12 days. I misspoke. I meant to say I'm going to pay you in 1,000,000,000 seconds. He gets his calculator out. How long is 1,000,000,000 seconds? 32 years. You see, that's not only a quantitative difference. That's a qualitative difference. He knows that ain't going to work. Oh, Bill, I'm sorry. I misspoke. I'm going to pay you back in 1,000,000,000,000 seconds. How much is that? 32,000 years. You see the point I'm trying to make? Million, billion, trillion. 12 days to 32 years to 32,000. Those are qualitatively different. We live in an economy of 14 trillion gross domestic product per year, carrying a debt of 800 trillion. Come on, what are you talking about? Check it out. It's important. Well, now let's get back to our subject at hand. How big is our galaxy? We can talk about all kinds of things and still not relate to how big the galaxy is, okay? There is a model suggested in the handbook of the Celestial Handbook by Burnham, that's worth our consideration. It turns out it takes advantage of a coincidence. It turns out that the number of inches in a mile turns out to be about 63,300, give or take, the number of inches in a mile. It also turns out that in astronomy, a standard unit of measure is called an astronomical unit. It's the distance between the Earth and the Sun, okay? It turns out the number of astronomical units, which happen to be about 93 million miles, the number of astronomical units in a light year is the same number, almost. They're almost the same number. The number of inches in a mile and the number of astronomical units in a light year. That's going to be useful to us just to build a model, okay? The distance from the Sun to the Earth is called an astronomical unit. It happens to be 93 million miles. That's just a basic unit in astronomy. In Burnham's model, we're going to let 1 inch represent the distance from the Sun to the Earth, and we're going to let 1 mile represent a light year. You with me so far? Okay. Robert Burnham's handbook, the Celestial Handbook, 3-volume standard stuff. Okay. Well, the Sun is 880,000 miles in diameter. In other words, on our model, it's about 0.009 inches. So our Sun, in our model we're going to build, represent a dot of a very sharp pencil. Call it like a period at the end of the sentence. That's going to be our Sun. You with me? Okay. So it's 1/100th of an inch, a tiny little speck. All the planets will turn out to be within a 7-foot circle diameter. The Mercury would be 4/10 of an inch away from that dot. Venus would be 7/10 an inch from that dot. The Earth, by definition, would be 1 inch. 1 inch being an astronomical unit. You with me so far? Okay. Mars would be about 1.6 inches. Jupiter about 5 inches. Saturn about 9.5 inches. Uranus about 19.2. Neptune 30 inches. Pluto would be 39.5 inches, roughly a meter. So our whole model, if I was building the model of the solar system here, with the Sun being a little tiny period, the whole thing would occur within a 7-foot circle, 1 meter in radius, call it. Okay. You with me so far? Now, the nearest star is a entity about the same size of our Sun that's 4.5 light years away. Okay. If our nearest star is 4.5 light years away, I make a speck the size of the period. Here's the Sun over here. I've got the rest of it laid out 39.5 inches out here, right? I've got to make a representation of that star, Alpha Centauri, 4.5 light years away, which means it's 4.5 miles away. I suddenly have to get a larger piece of paper. Okay? So 4.5 miles away. The question to you is, how much gravity do you think is operative between a speck the size of the period and another speck the size of the period 4.5 light years away when I have to square the distance between them? The answer is gravity has no impact, has a negligible impact, right? If you imagine these two stars in the size of golf balls, one of them's here and the other one's in Denver. You get how much gravity is between two golf balls separated by almost 800 miles. You see what I'm getting at? So the Milky Way in our model would be 100,000 miles in diameter.
Pause here.
So you get it.
So he's going at a great length to explain this, but what he fails to assert in this moment, because I can see a lot of people who are less learned having a problem with this section in particular to say that gravity is negligible at this distance, but let us call back much earlier in the program to the fact that generally the scientific community already agrees with this. Like, that's the whole point of inventing dark matter and dark energy, is that there isn't enough mass for galaxies to hold together if you don't have them. So gravity between objects that we can see, including black bodies, that is things that don't give off enough light of their own to really be noticed, but we can tell that they're there gravitationally by gravitational lensing of distant stars. All of that stuff isn't enough to account for galaxies holding together, and that, like, the tendency in people, I think, is going to be to challenge this section when this section can be taken for granted.
Yeah, he's explaining scales.
Mm-hmm.
Of the vastness of these spaces. Now remember, in Newton's thing here, the square of the distances is the distances are squared, and they divide into, that minimizes the impact. So we're going to explore a little bit what I call the boundaries of reality. And I'm going to use Da Vinci's Vitruvian Man as just a symbol of man's reach. And we're going to take size getting bigger to the right. So things that are larger than man, we call the macrocosm, and that leads to the study of astronomy and astrophysics. And the great discovery of 20th century science was that the universe is finite.
Okay, so to visualize to the listener, the inverse square law or an inverse square law. Another thing that diminishes as the square of distance is the volume of sound. So what I want you to do is put some headphones in, listen to me talk, and then let the video play for a couple seconds, and then just take your headphones out. That's the inverse square law.
Yeah, that's good. Then put them on your table, and then go in the other room.
Yeah.
Finite. It might be big, it might be expanding, but it's finite, not infinite. That has staggering implications. That's what led to the Big Bang conjectures and other things. Huge, huge. We're going to explore the other direction for even more bigger shocker things, the smallness, which we call the microcosm. Let's talk for just a moment about the model of an atom. We generally represent it by a nucleus and electrons spinning around it, right? Now, we know this is obviously not to scale. We know that the nucleus is in the neighborhood about 10 to the minus 13 centimeters. Okay, that's very small, but it's measurable, all right? The electrons moving around that are in the neighborhood of 10 to the minus 8 centimeters. What we're interested in here is the ratio between them, okay? The linear ratio between them would be 10 to the minus 8 divided by 10 to the minus 13, or 10 to the fifth. What I mean is that the orbit of the electron, if I want to visualize it that way, is 100,000 times the size of the nucleus, right? 10 to the fifth, you with me so far? But that's linear. If I'm laying this out in terms of area, I've got to square that. If I'm going to talk about volume, I've got to cube it. So the volumetric ratio is that thing cubed, okay? 10 to the fifth cubed is 10 to the 15th. What does that mean? That means the amount of substance in the atom compared to the volume it takes is the same ratio as 1 second has to 30 million years. Let that sink in for a minute. I have a podium up here that feels pretty solid. Kim, our technician, would assure me that this is as solid as the technology can make it, right? Now, Bob Schober challenged that and says, no, there's nothing here at all. He's more correct than I am by a ratio of 1 second to 30 million years. This is mostly empty space. Why does it feel solid? Because the molecules that make up my hand are colliding with the molecules that make up this podium to create the illusion it's solid. And it's a very effective illusion, but it is an illusion. We are the victims of a digital simulation. Now,
Pause.
It turns out, if I take a lot.
He earlier said that metaphor reigns where mysteries prevail, or something like that.
Yeah, or mysteries reside.
Yeah. I think that him being poetic in this moment does the whole argument a great disservice, because most of your interaction with stuff is not really in interacting with it in a mass to mass way, but it is the electrical field around the stuff that make up your body interacting with the electrical fields in the others. Like, what it means to touch something is to be interacting with its electrical field, not to be colliding directly with an electron or a nucleus.
Yeah, your electrons aren't bumping into each other. They
right.
form a cloud that forms a negative charge that mush together.
Yeah, and the negative charges of the clouds around your molecules pushing off of each other is how you apply force to something. And were that absent, you would fall straight through other objects.
Yeah.
But you should take that to characterize what it is to touch something. What you shouldn't do is slap someone and say, I'm not touching you because like my nuclei are not touching your nuclei. No, what we're doing here is we're changing the definition, or rather we're clarifying the definition of what it is to touch something. It's to interact with something electrically. Anyway, that's all.
I think this might even constitute a spoiler, but I'll say that the structure of an atom is command line.
You've been saying this for a while, and I don't seek out what that means because I want to discover what things mean during play.
Sure. But write that down.
All right, I'll throw that in my notes.
Yeah, throw that in your notes. These are as much questions for your future self as they are for your future self of me.
Okay.
Fine.
The future me that you get to access.
I have a piece of string up here, and I cut it in half. If I cut it in half, I could take the half that's left over and do that again, couldn't I? So I can take the half and divide it in half. I can take that half. I can keep doing that, right? Conceptually, you think I could do that forever. It might get too small to do it practically, but you could at least in your imagination, whatever I've got left, I cut in half, I throw the other way. It turns out there's a discovery to be made here, because if I keep trying to do that, I get down to a point, it happens to be 10 to the minus 33 centimeters, where if I cut that in half, that loses locality. It becomes everywhere at the same time. Why? Okay? It turns out that length is made up of indivisible units. They're called quanta. That's true of length, it's true of mass, it's true of energy, it's even true of time. Okay? If they get smaller than the Planck limits, they lose what we call locality. So we discover that there's a limit to largeness, the macrocosm. That's understandable, perhaps. We can sort of grasp that. What we
The resolution of the universe.
can't handle is we go smallness. There's a smallness below which we can't reduce. And we discover we are in a digital simulation. Okay? The Planck length is 10 to the minus 36 centimeters. Planck time is 10 to the minus 43 seconds. There's not a unit of time quicker than when the light changes and the guy honks behind you. No. The smallest unit of time is 10 to the minus 43 seconds. I'm convinced that the twinkling of an eye is 10 to the minus 43 seconds. Not the blink of an eye, the twinkling of an eye.
I want to give him credit for that joke.
Fair enough.
Like, he started saying something very serious and was like, the smallest possible unit of time is the gap between when the light turns and when the guy behind you starts honking.
Mhm.
He delivers it with sincerity and then just like corrects it and then plows right along. But like that's gold.
Yeah,
Well done, Chucky boy.
Good job.
Physical dimension we encounter, length, mass, energy, time, is made up of indivisible units. That tells us we discover that we're inside a digital simulation. And so this is the big thing. So if you look at the metacosm, the whole big picture, we are in a finite digital simulation. Now, scientists are concerned about some of these so-called constants of physics, and they're busily trying to verify the constants appear to be changing. Because not just speed of light, there's other constants they're even more concerned about. Scientific American, June of 2005. Their words: if these constants are changing, our universe is but a shadow of a larger reality. And when I saw that, it blew me away. I felt like saying, no kidding, Dick Tracy. That's what the Bible has been saying all along. The more you know about quantum physics, the more you know about the boundaries of our reality, the more you find that that is expressly mentioned in the Scripture. We now know that we live in 4 dimensions, not 3. That's what Paul says in Ephesians chapter 3, verse 18. He lists the 4 dimensions of our universe in Greek. Interesting. The more you know about the frontiers of real science, the more comfortable the Scriptures. You discover it's way ahead of us. And are we surprised?
And
Can we
now,
get a
and
citation
now
on
the
that
video
one?
starts.
Yeah. This is where the video really starts.
Yeah.
What was that chapter and verse again?
The more you know, as in Ephesians chapter 3,
There you go.
verse 18.
Are you looking it up right
Ephesians
now?
3:18. Yeah, I'm doing that in the background.
Okay. Should I also do that?
Go ahead and look that up on Blue Letter Bible for me.
That's what I am currently doing.
Yeah, I have a Blue Letter Bible app on my phone.
So
for
do I.
Exactly situations like this.
Now, see, I have no idea where Ephesians is, so I'm reading through all the titles of all the books.
Oh, if you go to search and type in EPH 3, it'll just take you there. And then you scroll down to verse 18.
Last thing I looked up on Blue Letter Bible was Jesus.
Let's see. I really love that the Greek word for height is upsos or upsos. Knowing that our word of up comes directly from Greek is very funny.
Okay. So we got one translation. No, wait.
Platos.
Yeah, my two versions of this are the New International Version and the ASV version. Well, no, they're both very different, but they both have 4 measurements.
Yeah, I'm in the interlinear section. Platos kai mekos kai bathos kai upos.
I don't know how to use this dang Dagnav app.
Are we doing
tap on the verse and then hit interlinear, and that's the thing that I do to look through this stuff.
Okay. Gotcha.
You want to explain to Sai what we're doing?
I know what we're doing.
Lining.
This is highly relevant to lining. Yes.
There's been, I think, 3 or 4 times where I've gone, oh, that's a command line. Do you want to list what some of those were? Good buddy Tarbuck Transom. Also, we're recording this.
I love the myths of science. That's such a fucking baller title.
Yeah.
Yeah. I'm not going to list it to try and encourage Simon to watch the video because I know that they're not going to stick around for the whole thing.
All right.
He lists the 4 dimensions of our universe in Greek. Interesting. As the more you know about the frontiers of real science, the more comfortable the scriptures. You discover it's way ahead of us. And are we surprised? We shouldn't be. Okay. So we have molecules. If we take some of these atoms and they'll start sharing electrons, making molecules and so forth. That's going to lead to something else I want to talk about. If we take gas and add energy to it, it becomes plasma. And if I use these symbols of the larger symbol being oxygen and the other little symbols being hydrogen, if they are together but the energy is so high that they're not directly associated, that is a ionized gas called plasma. If it cools down a little bit so that the hydrogen atoms stay associated with the oxygen atom, that becomes H2O as we think of it, as a gas. We call it, it's as a gas. And if we cool it down a little further, it becomes a liquid. That's the way we generally encounter H2O as a liquid. And if you cool it down further, it becomes a solid. Sometimes that solid will be in the crystalline form, but it's still a solid, okay? The real point I want to make here, there are 4 states of matter. In school, we typically are aware of 3 of those. A solid, add energy, it becomes a liquid, add energy, it becomes a gas. Add energy, and it becomes a plasma. Many writers in the press confuse plasma as simply an electrified gas. No, it's a different state of matter. It has behavior that's distinctive, and that's the shocker that comes out of all of this. And so the 4 states of matter. The entropy is maximized for the plasma. The entropy is minimized as a solid. Okay. Now, astronomers explain their views about it. See, they can relate to gravity. We can visualize gravity every time an apple falls to the floor. We understand gravity, we think. So they try to explain what...
Myopic cul-de-sac is a King Gizzard lyric.
Yeah.
Oh man, finding out that King Gizzard listens to Chuck Misler would be as crazy as when we found out that Robert Downey Jr. likes Chuck Misler.
And he did not know, but he had already entered the myopic cul-de-sac. Only one way to enter and one way to leave.
Now you're just doing what are the names? You're just doing a McElroy Brothers bit right there.
Yeah, that's true.
That was the voice you were doing.
Yeah. Yeah.
Now what the fuck is myopic cul-de-sac?
We're really about to kick off, so I don't want to put too much like barrier to watching through on this, but I do want to highlight that one of the unintuitive aspects of a plasma is that the viscosity of the thing can go up as energy increases, which is how you get like billowy effects on it.
Yeah, that makes sense. That tracks with what I know. You know what viscosity is?
A viscous something?
Yeah. So sticky.
Yeah.
That's,
I know that word.
What they think they know about the universe.
I mean, it makes sense that it's more sticky because as plasma, because it's like everything's free floating
In just like an energy gel.
Well, it's electrons.
Yeah, it's
separated from their
nuclei. It's like, what if gas was a metal?
Yeah.
Universe in gravity terms. They rely on 17th and 18th century tools of their forefathers, Kepler and Newton, whenever they deal with gravity, fluid mechanics, magnetism, lodestone, rather than those tools of the 19th century. They never bothered to learn James Clerk Maxwell's discoveries.
Double checking. Fire is just plasma, right?
It's okay, kind of. Most of what we think of as fire is light being given off by a chemical reaction between gases, but there are fires that are plasmas.
Like if you burn a log.
I don't remember the minimum temperature at which the gases involved become plasmas. It is different for different gases.
All right.
People going electrical engineering really learn that stuff and produce products as a result of that. But like I mentioned, the electromagnetic field theory. Furthermore, the astronomical conjectures are not empirically based. They're not done by scientific method. They're conjectures upon conjectures. They ignore data that does not support their presuppositions and the preconceptions. Therefore, they must postulate particles they've never seen and forces they have not experienced. If you read about the frontiers in astronomy, constantly talk about particles they're spending a fortune on trying to find particles that they've never seen.
Yeah, but they
and
found
forces that they haven't experienced. Why are they hunting for them? We have no reason to believe.
That's not a joke.
That's not the ones he's talking about.
That's what I'm talking about. That's a criticism people of that project.
Yeah.
We should not, shun science for like, oh, but you don't even know if the thing that you're looking for is true, dumbass.
Well, all right. He's not just talking about that one. Like the main one that he was talking about earlier was gravitons, which relies on a certain moiety of gravity.
Yes.
From memory, I think we found some evidence that correlates to gravity waves, but not direct confirmation of gravity waves the last time I checked. So jury's still out as of right now.
Please proceed.
Flames contain plasma.
Yeah, sorry, the Edward Elric atheist has joined the chat.
I really like that you've recuperated that that label that I've given you.
Uh-huh.
All right, let's keep it going.
Believe they exist? Not really. If you've been through some of our materials on quantum physics, you may remember this chart. I only want to get one number out of it. We have gravity and electromagnetic and their relative strengths. Electromagnetic strength is about 10 to the minus 2 of the strong force. The gravity is 10 to the minus 38. It's the ratio between those two I want you to be aware of. The electromagnetic force, there's 4 forces in the universe, but the electromagnetic force in the universe is 10 to the 36th times as strong as gravity. I want that to sink in. Not 36 times, 10 with 36 zeros after, times as strong. It can be that much different, okay? And by the way, it can go positive or negative. Gravity attracts but doesn't repel. Electromagnetic does both. Oodles more, okay? Now.
Dude.
You gotta speak up a little bit.
Dude, imagine if gravity repelled stuff.
The effects of gravity are minuscule. The effects of electromagnetism can be 10 to 36 times as great.
You ever hear of a white hole?
Tarbuck? You might be surprised to know that I have.
Yeah.
I don't know about the blue hole.
Is that like a blue waffle?
Oh, God,
if your hole is blue, you should see a doctor.
Yeah.
The entire volume of our galaxy is filled with diffuse clouds of magnetized plasma, electrically charged ionized particles. 99% of the matter in the entire universe is in the form of plasma. There's no missing mass. It's in a form that's been ignored by the astronomers because it may not be visible, because plasma is only visible under certain conditions. Now, on August 8th of 2010, there was a hidden aurora found near New Zealand. This was observed from the International Space Station. You're looking at this from above it, and it's obviously, if you make a guess, that looks electrical to me, right? I'm surprised it is. So what we're going to discover is there's a group of pioneers, scientific pioneers, that are all from Sweden or Norway, the high latitudes. Why? Because they're confronted with the auroras, and they got curious. What is an aurora? They started studying. Christian Birkeland is one of those, 1867 to 1917. He made a heroic commitment, gathering data. Instead of theorizing, he went out in the cold.
I wonder what religion Christian Birkeland had.
They just name people like that, so who knows?
You never met someone named Christian?
I've met like 4?
Yeah.
No, I'm just joking.
I've met a C. Weston Chandler, if that's what you mean.
Yeah,
Long night. They're nice. They go for months, right? And gathering data, risking his life. In gathering that data, he learned a lot about auroras. He was the first to recognize the electrical currents flow from the sun to excite plasmas in the Earth's upper atmosphere. He discovered the twisted corkscrew-shaped high-intensity currents in the plasmas that follow magnetic fields rather than across them, the so-called Birkeland currents. And he was nominated for the Nobel Prize in Physics 7 times. His portrait remains on the kroner, the 200 kroner Norwegian currency to this day. Interesting guy. He was succeeded by Irving Langmuir, 1881 to 1957, roughly the same birth and death of my dad. It happens coincidentally, that's why I happen to remember it. He discovered the double sheath or the double layer effect in plasma. I'll show you that in a minute. He coined the term, he's the one that coined the term plasma to describe the almost lifelike, self-organizing behavior of these ionized clouds in the presence of electric currents, magnetic fields, and foreign bodies that are inserted in them. These plasmas start to behave in an organized way because of the laws that they follow, which are very different than non-plasma materials. He invented the Langmuir probe, which is used to this day for research here. Now, there's double layer phenomenon. One of the most important properties of a plasma is its tendency to isolate one section from another electrically by a wall of two closely spaced layers. They call it a double layer. One a positive charge, the other negative. It does this intrinsically to protect itself from intrusions. A DL, or a double layer, is this where the strongest electric field will be in any plasma will be found. And plasmas isolate themselves from foreign intruders by surrounding themselves with a double layer as a protective sheath. That's just, they have a behavior. It's almost as if they have their own intelligence, so to speak. Well, he was followed by Hans Alfven.
All right,
1995.
that one right there. That's one of the big ones. That is him. It's almost as if they have their own intelligence. No, I don't agree because this is clearly a phenomenon by necessity. That is not what intelligence is.
Yeah.
Yeah.
I did read. too bad.
We haven't even gotten to one of the big ones, but like I wanted to like just stop it right here and be like, no, that one's wrong.
Yeah, no, that
But where mysteries lie, metaphors reign.
Yeah.
yeah, but like, does he? I feel like it's hard to interpret anything this guy says as a metaphor.
Yeah, sometimes he's being poetic, and you can see that in cases where his phrasing of the same concept in different places changes to give more summary for because the people he's talking to don't care. They don't care about technical accuracy the way that I care about technical accuracy.
Yeah.
But sometimes he'll say the correct version just seemingly just to prove that he does know the correct version and that he's summarizing the way that you might summarize if you were writing for the Discovery Channel.
That's good.
In recent years here, this is a new technology. And this guy was first to predict the large-scale filamentary structure of the universe back in 1963. That's when it first proposed, by the way. He first proposed the mechanism for the acceleration of cosmic rays, now known as the Fermi mechanism. He was awarded a Nobel Prize in Physics in 1970, and on it goes. In February of 1981, 11 years after Swedish electrical engineer Hans Alfvén won the Nobel Prize in Physics, he published Cosmic Plasma, a book which is largely ignored by the astrophysics community. And what you're going to see here is stuff that the astronomers, the astrophysicists, have chosen to ignore, to their peril, as it turns out. Our space probes have confirmed...
Yeah, sorry, that one can be on the reading list.
Oh,
Yeah.
his views. So this is giving the point we've got evidence now. Over 99% of the universe is composed of electric plasmas. And they obey, here's the important thing, they obey the same laws as small laboratory plasmas do here on the Earth. We can recreate these shapes and forms in the laboratory. We understand that behavior, and it turns out we're observing that behavior in the galaxies. So you're getting empirical confirmation here. We get to Anthony Barat. He's an author of The Physics of the Plasma Universe, which I encourage you to get a copy if you're technically oriented. Numerical and experimental contributions to high-energy density plasma, intense particle beams, explosively driven pulse power generators. You can already tell this thing's getting classified, isn't it? Lasers, intense power, microwave devices, particles, high-energy density phenomena, Z-pinches, and a bunch of other things that I'll show you up here in a minute. He's at the Los Alamos National Laboratory from 81 to the present, serving applied theoretical physics division, and so forth. And he's also scientific advisor in the United States Department of Energy, where he serves as acting director of national security and nuclear proliferation and so on. He made large-scale simulations of the Maxwell-Lorentz equations, and he was able to yield the same results in those simulations that are indistinguishable from the astro images from actual galaxies. And here's a group of the pictures. These were done in the laboratory, and we see the same shapes and behavior that we observe through telescopes. So it's interesting confirmation.
All right, that's one of them. Okay, so what we're saying here is that, remember earlier when he was like decrying certain kinds of models? I just want to bring that back right now because it like that logic could be used to criticize these models. Like there's a qualitative difference there in that these are scale models of plasmas in a laboratory, but that is assuming that a like action upon a plasma in a small scale, like something that you could hold, is comparable or tells us something useful about a macrocosmic scale object.
Yeah.
I want to remind everybody that you can only experience laminar flow at the human scale. Below the human scale, you get turbulence. Above the human scale, you get turbulence only.
Yeah.
That's interesting. I do think about it sometimes about like, man, I feel like when there's like just a little, like a tiniest trickle of water and like a huge like torrent of it, you know, there's like a sliding scale that is never like traits are never replicated across that sliding scale, really.
Mm-hmm. Yeah, and so I just wanted to highlight his use and criticism of models earlier for this moment where he trusts the model now for reasons that I think if it were presenting different facts, he would be critical of.
Well, Tarbuck, he trusts the model because it verifies the thing that he believes.
Yeah, I'd want to know the path that he took to get to these beliefs.
Sure. I think
how, like, what is the order in which these things were presented to him?
You can you know, craft a model and attempt to have it model anything. You know, make it believable. because you were.
And well, yes and no, but anyway, we should get on with it.
Okay.
The gravity are minuscule. The effects of electromagnetism can be 10 to 39 times more. The entire volume of our galaxy consists of magnetized plasma. 99% of all matter is plasma. Here is a picture of M31. You've seen this in all your astronomy textbooks. A very common picture of Andromeda, as it's called, right? That's invisible light. Let's take a look at this in infrared. And you begin to see the electric structures that underlie that thing. And if you look at M82, and if you look at it in other frequencies, you realize it's a plasma structure. If you look at it infrared. As you look at these, you begin to realize that there are aspects to those structures that are not normally visible in light. And you almost see the axis, and you can see the other behavior. Maxwell equations. There are 4 partial differential equations that relate electric and magnetic fields to the sources, charge density, and current density. And these equations can be combined to show that light is an electromagnetic wave. The interactions of electrostatic and electromagnetic forces are very non-intuitive. One of the problems in this area is we're not talking about 1 or 2-dimensional relationships. We can deal with 1 or 2-dimensional relationships. We can't normally deal with mutually orthogonal relationships. I'll show you what I mean. The forces are orthogonal to the fields, and the resulting plasma takes on a unique aspect as a composite body with a very distinctive character. You see, the magnetic field is in one direction, the velocity is in a different direction, and the force is that these are all mutually orthogonal. And each one is 90 degrees from the other, and that their behavior among themselves is very non-intuitive. You've got
Yeah, thanks, Doom.
Yeah.
Teaching me orthogonal. Really
experiment these to get a feeling for how plasmas behave, because these are all mutually orthogonal. Are you with me so far? Okay. In fact, the engineers will speak of a right-hand rule. If you have an electric current, around that electric current there'll be a magnetic field. If the current is changing, the field will be changing. If the field is changing, the current will be changing. They're intrinsically hooked, and they're hooked with what they call the right-hand rule. You put your thumb in the direction of the current, your fingers will point in the direction of the field. You with me? They're inextricably linked. Okay, you don't have one without the other, and that's the net of those equations, the so-called right-hand rule. Now, it turns out that plasma you don't normally see. It has 3 modes. It can be dark where there's no light admitted. You don't see it normally. The Earth's ionosphere.
Now,
normally, and that's the net of those equations.
The right-hand rule. This is something that I think you could build a religion around.
Yeah, how I agree. I did.
Yeah.
Yeah. That game you played.
Yeah.
Yeah.
You mean Dwarf Party?
Sci Wars.
Oh, Sci Wars. Right.
I think I got pretty close to this.
Yeah. Who was I talking to? I don't remember who I was talking to. I think I was talking to some normies at one point. Yeah, I know. Woe is me.
Okay.
Where
you said that.
Yeah.
Anyway.
Where they were like, "Oh, you went to Australia? Oh, yeah, all the toilets are backwards there, right?" I'm like, "No, that's not true." And they're like, "What?" I'm like, "Yeah, that's not how that works." And they're like, "But the Earth's spinning different down there. Like you're on the bottom of it." And I'm like, "That's doesn't matter."
Down's the same wherever he is.
And they're like, "But like that's where it comes from. It like spins." And I'm like, "No." Like, if you have I try to explain, like, if you have a drill, you can spin either way. It doesn't have resistance because you're on the Earth.
Mm-hmm. Or more to the point, the spin in a toilet flow is not the result of the Coriolis effect. It's the result of imperfections in the bowl itself, which you might know if you had ever looked down at more than one toilet in your entire life, because they just do spin in different directions from each other.
I wasn't explaining that to one person. I was explaining that to 3 people at the same time. I don't remember. I think I was at a work thing? I don't remember. Or was I in a doctor's office? I don't remember when this was. But they were like 3 strangers.
So-called right-hand rule. Now, it turns out that plasma you don't normally see. It has 3 modes. It can be dark where there's no light admitted. You don't see it normally. The Earth's ionosphere, except during auroras, is invisible. Okay? Electric current, if the current is very, very low, you don't see the plasma. Now, you add a little more current, it goes in what they call the normal glow mode. When you see a neon sign, that is in the glow mode. It's a plasma. It's going through that too. It emits light. Auroras, emission nebula, the sun's corona, and comet trails are all examples of plasma that is in normal glow mode. The brightness intensity of the current, the intensity of the plasma, and so forth. The color depends on what gas is being ionized here. Okay? Then you get to the bright one, the arc mode. You got dark, normal, and then arc, which is extremely bright and a very wide spectrum of emission. Electric welding. You never look with unprotected eyes at someone doing electric welding, because you're seeing arc and it has frequencies that will hurt your eyes. The sun's photosphere. You never look directly at the sun. And lightning. Fortunately, so brief it won't do that much damage to you. and sparks are examples. It's characterized by twisting filaments both in the ultraviolet and in the radio frequencies. We also encounter a strange thing called the Z-pinch effect. High-intensity current passing through a plasma will take on a corkscrew or spiral shape. This was discovered by Birkeland, so they're called Birkeland currents. They most often occur in pairs, and they tend to compress between them any material, ionized or not, in the plasma. And they call this the Z-pinch effect. I'll show you that in the diagram in a minute. Cosmic matter tends to form an abundance of these filamentary, stringy kind of structures. The initial velocity of a particle is perpendicular to the magnetic field. The path that the particle takes is a circle in the plane perpendicular to the field. However,
I wonder if everyone else in this audience right now is just zoned the fuck out. I wonder if they're
like this. To me, this is the point of the video. This like we're getting into the meat of the real. Like this is why I posted it.
Where does the God come in?
You'll. In a way, we're past it, and in a way, you'll see in a minute.
I see.
It's like Book of the New Sun that way.
Right. I wasn't gonna say it. Yeah.
Speaking of new suns.
Yeah.
If the initial velocity of the particle is
there's a Star Trek joke here.
Different from 90 degrees to the magnetic field, perhaps slightly in the same direction as the field, then the path will be a helix or a spiral. The stronger the field is, the smaller the radius of the circle will be. No matter what the initial direction of the current stream, it will end up following the direction of the magnetic field. And here's a diagram of that. It's called a Birkeland current. Okay? It starts at a helix and gets tighter and tighter and tighter. And that's the side view there on the left. To the right, there's the top view. And what's being squeezed in there is called the Z-pinch. Whatever material in there is being squeezed by the Birkeland current. This just happens naturally within a plasma. These are very non-obvious things. The only way to discover this is by playing with them in the laboratory and discovering them. Both in the laboratory and in the cosmos, a pair of such spiraling currents will be observed. The interlinked pair will at first be magnetically drawn together, but after a certain proximity is achieved, the force of the repulsion is generated that holds them apart. This configuration turns out to be extremely stable. That's why it can span such enormous distances in our galaxy. The resulting tightly worn pair is called a Birkeland current. The attractive repulsive forces acting on this pair of currents creates a twisted, constricting cylindrical volume inside the spiral where extreme compression of matter can take place. When this occurs in cosmic space, the associated plasma filaments can be observed by the radiation they emit. Now, don't confuse this with the conjectures of gravity people about black holes. Black holes are conjectures.
Gravity people.
Black hole.
We're not one. The gravitational lensing effect around a black hole means that black holes, are not conjectures. We know that they're there.
Yeah.
Which I think he should know. And like I can do some theology of black holes stuff at some point, if you want to get in there.
That sounds sick as fuck.
But
I'll join that religion.
I mean, it's not that much different from stuff that I've already told you about the bulk and the boundary, which is homework that we assigned to the viewer earlier in this video.
Mm-hmm. I'm going to back that up a little bit.
Cylindrical volume inside the spiral where extreme compression of matter can take place. When this occurs in cosmic space, the associated plasma filaments can be observed by the radiation they emit. Now, don't confuse this with the conjectures of gravity people about black holes. Black holes are conjectures. They're conjectures.
No, I thought gravity people was really funny.
The gravity men, they're upon us.
Yeah, it's like that's like calling flat earthers coin people.
Have you guys been riffing on this as hard as I've been?
We're now in the meat of the video, so there hasn't been this much material to riff on until now.
Well, good. I'm glad I got here at the right time.
You did.
Now, don't confuse this with the conjectures of gravity people about black holes. Black holes are conjectures. They're conjectures that are driven by a dependence of gravity. Gravity is not a factor. The plasma factors are. The scripture talks about stretching the heavens. Have you noticed that in the word? The fabric of space. Is this more than just a metaphor? Who alone?
Yeah, I want to know what he means by black holes are a conjecture.
He doesn't follow up on that in the rest of the video, but he hasn't said the craziest shit yet. So let's keep going.
Stretches out the heavens in Job 9, stretching out the heaven like a tent curtain in Psalm 104, who stretches out the heavens like a curtain and spreads them out like a tent to dwell in Isaiah 40. Are these just figures of speech? He has stretched out the heavens, Jeremiah 10, the Lord who stretches out the heavens in Zechariah 12, and on it goes. I could go on and on with these phrases throughout the scripture. They're familiar to you. Too consistent to be just figures of speech. Space, by the way, we discover, is not an empty vacuum. That's the presumption of science fiction writers who haven't done their homework. Space can be torn, Isaiah tells us in 64, chapter. It can be worn out like a garment, Psalm 102 tells us. It can be shaken. Can you shake empty space? Hebrews 12, Haggai 2, Isaiah 13, I'll make those references. Space can be burnt up, according to 2 Peter 3.
Can you get my plate and put a slice on it? Thank you.
You want to talk about global warming? Peter will explain it all to you in the 3rd chapter of the 2nd letter. Here's the interesting one. Space can apparently be split apart like a scroll. Really? Revelation 6. It can be rolled up like a mantle or a scroll. Now, wait a minute. For something to be rolled up, it must be in some sense thin, and there must be an additional dimension into which it can be bent, right? The grammar requires that. Rolled up. See, there must be some dimension which it can be thin, space can be bent, then there must be a direction into which it can be bent upward. Thus, there are additional spatial dimensions, and 10 is a current estimate. The 4 we directly experience, and 6 that occur in less than 10 to the minus 35 centimeters, or the smaller, it can only be inferred indirectly. Now, we also run, if you run into astronomy, you discover the Heisenberg formula. That's the barcodes of the atom. The spectral lines of hydrogen at unlogarithmic scale directly.
On this one?
Okay. Yeah, okay. So, furled at scales less than 10 to the 35, no? Okay, so if you have more than 10 dimensions, if you have more than 4 dimensions at that space, or at that scale, then necessarily you also have more than 4 dimensions at all scales. You're just not interacting with them.
Yeah.
I thought you agreed with like literally everything this guy said.
No.
No.
Okay, yeah, no, you're
like,
right. That's
like,
not true.
He doesn't like the gays.
Oh, that's unfortunate.
He's also dead.
Yeah, like
that's good.
there's some theology stuff that I don't agree with him on. Like, I think most of his stuff is better than most other people. Okay. But like this guy is like the like, I'm gonna go ahead and give it like the B+ mode for Christian thinkers, as far as I'm concerned.
Yeah, B+, homophobic see me after class.
He's also not an annihilationist. Which,
what's that Mario about? The Mario paper? What's written on that?
Oh, so much.
Yeah.
So much shit is written on that. Mario versus Mario deal.
The 4 we directly experience, and 6 that occur in less than 10 to the minus 35 centimeters, or the smaller, they can only be inferred indirectly. Now, we also run, if you run into astronomy, you discover the Heisenberg formula. That's the barcodes of the atom. They're spectral lines of hydrogen.
Yeah, no, dimensions, they might have different scales in which they operate. Like, the universe might be taller than it is wide or something. But, like, they're probably not on the smallest possible scale.
Yeah. The magnitudes involved here are nonsense. When I think of holding the firmament in place, what I think of is preventing drift in 10 dimensions.
Logarithmic scale in this particular illustration. And it was invented by a Swedish physicist, Rydberg, in 1888. It's used in atomic physics to describe the wavelengths of the spectral lines of chemical elements. Very interesting, except we discover certain stars have their lines shifted to the red, but not always, sometimes to the blue. Ooh, why? The so-called red shift. Back in the 20s, Edwin Hubble suggested what was called the Doppler effect as an explanation. He felt that the red shift was caused by these stars moving away from each other, like the Doppler effect. That remains, to this day, a widely accepted explanation, even though it's been punctured, by the way. In 1976, William Tift of the Stewart Observatory in Arizona noticed and documented the aberrant and digitized nature of red shifts. He spent 20 years doing this. In 1980s, Guthrie and Napier at Edinburgh Observatory spent 10 years challenging the view of Tift and confirmed that Tift was correct, that these shifts are digitized. There's specific steps, which says they can't be a Doppler effect. They have something intrinsic to do with the molecular structure. Robert S. Millikan in 1925 noticed that the wavelengths of spectral lines were shifted from their theoretical position and was among the first to recognize that energy in space was battering the atoms and affecting their movement. These spectral lines are due to electrons moving between the energy levels of the atom, not the Doppler effect. And yet you find these old myths still populating our textbooks in college, let alone high school. Now, the ambient energy in what we think of empty space has come to be called the zero-point energy. And boy, this is a whole area of controversy in its own right. Zero-point energy, we think of empty space.
So, that last part was about how Doppler effect, no.
Right.
Actually, it's about the charge level of the plasma.
Yeah. That sounds plausible to me.
Doppler effect, I live on road. I hear road noise.
Yes, we experience the Doppler effect. Often.
Yeah, but the thing that specifically he's talking about is Doppler effect at near luminal scales, causing red shifting due to the expansion of the universe via dark energy. That's the thing that he's criticizing.
Yeah.
See me after class.
That's a I want to see the teacher after class.
Yeah.
Yeah. That is the like punchline delivery on his thing from earlier about gravitationally entangled or affiliated stellar masses having like being close to each other and being close to each other in speed, but having different redshifts on the light that they produce.
Mm-hmm.
That doesn't make sense if it's the result of the Doppler effect, but it makes more it like I would have to plumb the math on it, which is honestly beyond my ability to do personally. So I would have to rely on a different expert who's not into this shit and doesn't know exactly what he would be working on. You don't want to spoil the pot, but it seems plausible to me from
we
the
talked
outset.
about that for like literally 10 minutes earlier.
Yeah,
that we're just talking about.
Yeah.
It's plausible to me from the outset that differences in charge resulting in different electrical emissions makes that redshifting problem go away.
Yeah, I wouldn't disagree with that.
It requires some like wildly different cosmology to get there, but it does sound not instantly dismissible.
Yeah, you could assert a hypothesis.
Especially the super cool and all that sort of stuff, as being an empty vacuum. Anybody here's a radio ham? If you're a radio ham, you try to tune your antenna to the impedance of space, right? You mean space has impedance? Absolutely. Every radio ham knows that. Max Planck in 1911, and then Einstein, Stern, and Nernst also recognized that this pervasive energy was a universal phenomenon intrinsic to space itself. Through the work of Heisenberg and others, it began to be understood that Planck's constant was actually a measurement of the uncertainty in the position of subatomic particles. By 1962, it was realized that this uncertainty of position was caused by the battering from the zero-point energy. The Heisenberg uncertainty effect is widely misunderstood and it's, of course, explored by New Agers who don't understand anyway, but that's neither here nor there. This energy is independent of temperature or mass, by the way. That's a surprising thing. In 1987, Halputov showed that the electrons stayed in orbits and did not go either spinning out or spinning in due to the expended energy, precisely because of the energy they received from the zero-point energy. You ever wondered why these electrons keep spinning? Why don't they slow down? Because they're growing on the zero-point energy. About 25 different methods, 475 measurements, and 11 different related quantities confirmed that E is equal to, that the energy, which is constant, is Planck's constant times the speed of light. If the speed of light is slowing down, then the Planck's constant is increasing. And that's disturbing because the disturbing it is, and that's pulling the rug out from much of physics.
So not getting into the Planck's constant is increasing, which, holy shit, that would be wild if true.
Big if true.
Mm-hmm.
Like, not just big if true, that is like reality shattering if true.
Yes.
Yeah, that's the things are becoming destabilized on a field level.
Yeah. That would point to a de-resolution of the universe. Which, I'll loop back around to that. I wanted to
Yeah, you want an 8-bit universe? 64 colors.
It'd be cool to perceive a shift in the way that reality is.
You would just die.
Yeah, it would be horrifying and terrible.
Okay, here's a symptom for you of the destabilization of the atoms in the universe. Remember that one speedrunner who skipped up to the top of a TikTok clock?
Yes, I do.
Yeah. Imagine if that just started happening more often.
I think we'd be living in a momentous time.
Speedrunners hate him.
Speedrunners hate him. By the way, this trembling of the 0-point energy that happens beneath the quark foam, that could be giving the electrons their continued orbit. If that's true, then I think that 0-point trembling is what is responsible for the pilot wave in pilot wave theory, which is the competing model to Heisenberg Copenhagen interpretation, or probability field collapse as you might understand quantum physics to be. Like there are alternate theories that produce the same predictions but have a different underlying model, and pilot wave is the one of those that I like.
Okay.
I think that pilot wave is true.
Mr. Transom?
Yeah?
I thought this was theology class.
We'll get there.
I understand most of what was said.
No, I understand most of what was said.
I don't know the theory you're talking about, but I know the one that you were talking about in opposition to.
Today, properties of space. The 0-point energy of 10 to the 95 ergs per cubic centimeter, and that's an unbelievable amount of energy for every cubic centimeter.
Ergs.
Ergs. This is not a unit that I'm personally familiar with, so I would need that.
Go back to
translated.
pawn hearts, nerd.
Yeah, how many mans per erg? Can we run that calculation?
How many man ergs?
Centimeter in space, empty space.
Here, like we'll do it. Here, we'll do it for the audience.
Are we?
Unit of work energy by a force of 1 dyne. It's 0.1 centimeter. Acting on a mass of 1 gram. Yeah. Moving something that weighs 1 gram, 1 centimeter.
Okay. All right. Now let's go back to his unit.
10 to the power of 54. Is that what that says?
Or 95.
Holy shit! That's a ton of energy.
Yeah.
10 to 98.5.
98.5.
Properties of space. The 0-point energy of 10 to the 95 ergs per cubic centimeter, and that's an
10 to the 95.
unbelievable amount of energy for every cubic centimeter in space, empty space. It has permittivity, the absolute electric constant. It has permittivity, it has permeability, it has intrinsic impedance. Anybody that designs antennas deals with these things. And the velocity of light is essentially at the speed of gravity today. Well, it's interesting. Hebrews 11:3 says, "Though through faith we understand that the worlds were framed by the word of God, so that things which are seen were not made of things which do appear." How descriptive. One of my favorite Psalms is Psalm 19. The heavens declare the glory of God, and the firmament showeth his handiwork. Day unto day uttereth speech, and night unto night showeth knowledge. There is no speech nor language where their voice is not heard. Their line has gone out throughout all the earth, and their words to the end of the world.
I want to point out how tempted I was to for Command X to put the things that are quotes on this PNG.
Does he use this often?
Yes, he uses this all the time.
Yeah, this
It
is
would
like
have been
his
really
main
funny
slide.
for just Tarbuck.
Oh man, that would have. If there's a third act to this game, you got to do that.
I don't know if it will be relevant. I just got an eyebrow raise at that.
I'm gonna let everyone figure out what's what.
Now, my professional technical background happens to be in the information sciences. I have masters and doctorates in a number of fields, but that's my primary specialty. I'm fascinated because this psalm has information science. Oh, and the other thing, as you study any field of science today, you'll discover that the frontier of that science lies in the area of information science. In the field of physics, you get into to quantum physics. It's an information science issue. If you go into microbiology, the whole thing is the coding of the DNA and all of that. That's an information science, switching theory issue and so forth. The information science is at the frontier of everybody's. The heavens declare the glory of God. The firmament showeth, these are information terms. Day and day uttereth speech, and night showeth knowledge. There is no speech, nor language, where their voice is not heard, and so forth. Their line goes throughout all the earth. Their words, it's interesting, this whole thing is information sciences. And it's interesting to me that one of the titles.
Their line has gone out all the earth, and their words the world.
Yeah, it's from the Book of Psalms.
All things are apart.
Mm-hmm.
And so forth. Their line goes throughout all the earth. Their words, it's interesting, this whole thing is information sciences. And it's interesting to me that one of the titles of our coming king is a Greek term for word, logos. How interesting. Their line has gone throughout the earth, their words to the end of the world. In them hath he set a tabernacle for the sun, which is as a bridegroom coming out of his chamber, and rejoiceth as a strong man to run a race. His going forth is from the end of heaven, and is certain to the ends of it. And there's nothing hid from the heat thereof. How interesting. You know, the cynics will say, see there, everybody knows the sun doesn't rise in the east and set in the west. No one said it did. That's not what he's talking about. And if you look,
I'm just going to let him say that again.
how interesting. You know, the cynics will say, see there, everybody knows the sun doesn't rise in the east and set in the west. No one said it did. That's not what he's talking about. And if you look at all of this, and look at a map of our galaxy, you know, the sun does travel literally from one end of heaven to the other in an astronomical sense. And it's interesting also, it happens to be in the location in the galaxy that makes it possible to see the rest of the galaxy. And that's one of Richards and Gonzalez's book, The Privileged Planets, is a must read, because you'll discover the universe was designed to be discovered. Not just for life, but discovered. The source for the entire solar system,
by the way,
is, of course, the sun.
Everyone loves The Privileged Planet.
Well, The Privileged Planet is at once mundane and fantastical in a way where, like, all of the information that they're sending is like, well, yeah, obviously. But then if you assemble it in this context, it's like, hey, wait a minute. I see what you're driving at. And then it turns out that they're not actually driving at, that most of those people in, like, everybody in The Privileged Planet proper is actually a secularist. And you have to go to, like, special features in order to get to people who have any opinion on religion other than being an Edward Elric atheist.
As that psalm suggests, and nothing to hid from the thereof. When you see an eclipse, you see the corona, and anyone that has any experience with electromagnetism can tell right away that is a huge electromagnetic phenomenon. Okay? It was designed to be discovered. If you take the size of the sun, the size of the moon, the distance from the moon from the Earth, and the distance of the sun, you discover that these dimensions have to be an exact number in order to see the corona.
Yeah, pause that.
It turns out
that's fucking insane to me.
Yeah.
That, I think about that sometimes and go, the fuck is that like that?
Why is, like, not only that, but Earth is the only planet that has a moon that's anywhere close to that, in terms of the proportionality of the mass between the moon and the planet that it orbits. And, like, all right, there's a lot of other features as to why our moon is really, really weird as an outlier.
Yeah.
Like, why is it not a ring, for instance? Why is it, and I could go on, but, like...
Yeah, earlier there was a, he brought up a model of the solar system. I pointed this out to Tarbuck, but I'm pointing this out to you now. He brought up a model of the solar system, and it was like the 8 planets, right? And then he goes, Earth and Mars are a pair. They spin the same way. Jupiter and Saturn are a pair. And then
two blue ones.
And then Uranus and Neptune are a pair. They all have matching spins and, like, matching axes, but they're all different from each other.
What about Mercury? Checkmate, God believers. Mercury and Venus don't spin the same way.
Anyways, I pointed that out, and then I went, yeah, that's why they're not there in Star Wars.
Yeah, that's why they're not canon.
They're not canon.
They aren't canon plants. Those are DLC plants.
It doesn't say that they're not like that, but I vaguely recall that.
The DLC plants were not integrated into the final cut.
Mm-hmm.
that these two distances, these rays have to be in a precise relationship. If it isn't, the moon will be too big to blot out the whole thing, or if it's too small, you'll be blinded by the rest of it. It's exactly the size in relationship. When the moon goes in front of that sun on a total eclipse, you can see the corona. And because you can see the corona, you discover spectroscopy. And out of spectroscopy, the whole universe starts to open up. And you begin to realize this was not only designed, it was not only designed for life on the planet Earth, it was designed to be discovered. And what a breathtaking thing that is to encounter. If you take a temperature profile of the sun, it's really quite surprising. Because the photosphere that comes through, the corona is at a higher temperature than the rest of it. That's a surprise. Well, I thought the sun was just some kind of nuclear explosion. That's a guess. That's way out of whack. The sun, you're going to discover, is a very sophisticated light bulb. It's electromagnetic phenomenon. This is the temperature profile.
This is it. That's what... When I heard him say that, I posted the video. Yeah, I was like...
I don't know if you saw my reaction to that. I went...
I can't see you.
I know. I said to Roma, I don't know if she can see my reaction, but yeah. I, like, blinked and, like, opened my mouth and then, like, blinked 3 more times and then closed my mouth and then tilted my head as I was processing that.
Yeah. No, this is like a nonsense statement almost.
It is a very sophisticated light bulb. It's an electromagnetic phenomenon. This is the temperature profile. If you take a voltage profile, it's somewhat the inverse of that. And as Bob Schober points out to me...
But pause, because I have more to say than just ridiculing that statement.
Yeah.
All right, so item 1. We know you can find the mass of the sun for reasons other than just believing that the sun is like really big. Like there are non-bullshit ways to get the mass of the sun than starting from our orbit and working backwards by looking at things like the gravitational lensing during a solar eclipse to like all right, so we can get the mass of the sun, and from the mass of the sun we can get the compression force, and from the compression force we can demonstrate that that would produce fusion. Fusion is happening in the sun.
Yeah.
Or I like you would have to do a lot of proof work to try and assert to me that that is not the case. I do want to like flesh out the thing that he's saying here, because like we've paused a lot between his Z pinching thing. He's claiming that the formation of stars was the result of like arrangements of currents in the galaxy, like along filaments, etc., to create a strong compression of mass in this spot, and the electrical compression and the confluence of electricity caused bright to happen. And part of his support for that, which he's about to say in a second, is that the corona is hotter than both the surface and the chromosphere.
Okay.
That part I can't dismiss immediately.
Yeah, that seems so easy to check.
Like not only is that easy to check, that is like one of the first facts that you learn about the sun when you go into the cool unintuitive behavior of the sun. Like I've known that about the sun since like second grade.
We just learned about how weed will make you blind in my school.
You were in many ways let down by everyone around you.
Yeah, I know.
Consistently.
I was taught Huey's Law in school.
I was taught Huey's Law on the streets.
Oh, yeah.
This is simply identical to a solid-state PNP transistor. Boy, is there a clue there. Is that the way the sun's getting its energy as it passes through the fields of the universe? I'm expecting Bob to put his hat on and figure out a way. Can we get a way to tap that energy for this one-set satellite system? That would be an exciting possibility. But there are electric currents in the sun, and here's a map of them. If you have a main current flowing in at both top and bottom, and they flow out at the perimeter, it creates secondary currents in each side, and those are now beginning to be understood. And if the main magnetic field starts to weaken intensity, a secondary surface current will reverse direction, and the magnetic polarity of the loops will also reverse. It does not depend upon the direction of the primary current. It's a question of strengthening or weakening. And these reversals appear to occur about every 11 years. And they have profound effects on what goes on the Earth, by the way. And so, if you have what we call a solar prominence, from a strong looping current will produce secondary magnetic field. It will surround and try to expand the loop. If the current becomes too strong, the double layer that contains it will be punctured. And if the voltage gradient becomes strong enough, the discharge path will break. The energy stored in the primary magnetic field will be explosively released into space, and you have what's called a prominence. That's piercing the double layer that produces what we call here a solar flare. How many have heard or seen solar flares? There's the electric diagram that explains them. Okay. Now here's a picture of the sun. There's the plasmatic field pictures of them. You can, by the very curvature, you can sense their magnetic properties here. Now, here is a very prominent solar flare. Let me show you the size of that. Let me put the Earth synthetically. It wouldn't get this close, but if the Earth was here, that's where the Earth would be. That's a big flare. That's the relative size of the Earth on that flare. Now, I'd like to show you, and hoping this will work.
Yeah, but that's just like the sun is really cool, you know. That's not like the fact that solar flares are plasma arcs and that they follow electromagnetic curves, like curves in the field as they go along. That's trivial information. You can't use that to prove anything.
That's true. It's sick as fuck that you put Earth.
Oh yeah, I think about that all the time.
It is.
That will show you these flares, and you see them in motion. It doesn't take any imagination to realize what you're watching there is magnetic phenomenon, following the lines of force of these magnetic fields. These are incredibly descriptive, and that's not gravity at work, that's electromagnetism at work. Those are Birkeland currents that you're watching, okay? Well, anyway, we'll move on here. Look at a leaf. You discover that it's been designed to take those frequencies from the sun and produce a lot of different things. You have a thing called photosynthesis, which is turning built with light. These are sugar factories with millions of new glucose molecules per second. Most plants produce more glucose than they use in storage of starch and other carbohydrates and wheat stems.
the unthinkable might and power of the fucking sun, dude. It's so big. This is how big fucking Earth is. The craziest thing in the world. Here's a leaf.
Yeah.
And those two things are like so intrinsically linked, obviously, as he is explaining.
Mm-hmm.
But here's a leaf.
Yeah.
Here's the leaf.
It's a real
It's a
anticlimax.
sugar factory.
Millions of glucose molecules a second.
Leaves. Each year, photosynthesis organs produce about 170.
More plants produce more glucose than they use and store it as starch. And they store stuff. It's true. About 170
Yeah, here's where we get into the trivial assertions section.
extra carbs.
Billion metric tons of extra carbohydrates, about 30 metric tons for every person on the Earth. So we have an amazing dependency, not only the design of the universe and the design of the sun, but how the plants produce the oxygen and the sugar to feed the animals, and how the animals produce the CO2, which causes the whole thing to work. And we find the interconnection here is so complex.
Plants don't need animals to produce CO2 for them. They can process oxygen into CO2 and CO2 back into oxygen. They're self-sustaining and they not need animals to live.
Yeah. Also, like,
I would wonder about the ratios on that, but it's also fungi also produce CO2. Like, you don't need animals.
Yeah, and like bacteria.
Yeah. Dying plants produce CO2.
Yeah, because they.
Now, what would be the equilibrium of that if we killed every animal everywhere? I don't have an intuition of that.
Perhaps plants might be less prolific to an extent that would reflect the depreciation in CO2.
Well,
all those weird Stargate planets that just take
oxygen
place.
poison themselves to death.
Think about all those weird Stargate SG-1 episodes where they go to a planet that's totally unoccupied and it just looks like the forests in Washington, where it's just pine forests across an entire Northwest, where it's just a pine forest. It's the entire planet.
Just Endor.
Yeah.
Endor has cute little teddy bears.
I often also think about one time we went to a when I was a little kid. We went to a place where you like ride dirt bikes or whatever. It's like they have miles and miles of trails and like race tracks and stuff like that. The trees there were all really healthy. And they all looked really good, which was counterintuitive to me because people are like driving around motorized stuff all the time. Mm-hmm. And I assumed that's because it's like, oh, they just have so much carbon dioxide debris that are like all really verdant and green.
Interesting.
So when you have a really high density of carbon dioxide, plants grow faster, but as a result, they tend to grow weaker. This isn't why wood these days has fewer rings to it. That's because it's grown like in clear-cut fields, but it is a contributor. If you were to grow like a bean pod in a low oxygen environment versus a high oxygen environment relative to the CO2, the spaces that have the more CO2. Say again?
If you're an anarchist and you're growing your beans.
Yeah. The ones that grow in the higher density of CO2 grow faster and as a result less dense, and as a result they're just made of less stuff. They're flimsier.
Mm-hmm. Continuing.
I couldn't take quite a part of an hour just to explain the different steps of the photosynthetic process. But the elegance of design, the more you study it, staggers you to realize the degrees to which God went to provide the environment that we enjoy every day. Genesis chapter 1, and God said, let there be a firmament in the midst of the waters, and let divide the waters from the waters, and God made the firmament which divided the waters which were under the firmament from the waters which were above the firmament, and it was so.
The waters.
Mm-hmm.
Yeah, water's important. In the midst of the waters. Here you go. Here. I'll let you line a little bit. Here, let him go.
The degrees to which God went to provide the environment that we enjoy every day. Genesis chapter 1, and God said, let there be a firmament in the midst of the waters, and let divide the waters from the waters, and God made the firmament which divided the waters which were under the firmament from the waters which were above the firmament, and it was so.
Let there be firmament in the midst of the water that divide the waters from the waters. Moving the water up top and the water down below. Yeah. What the firmament does.
Yeah.
So there's like the lakes and stuff, and also there's all the stuff that's up top.
Yeah.
God made the firmament and divided the waters, which were under the firmament, from the waters, which were above the firmament. I don't know why. Okay, I got there.
Yeah, no, this is just like
Yeah.
Here's what I'll say. I'll say that this passage is like Eminem lyrics.
Firmament in the midst of the waters, and let divide the waters from the waters, and God made the firmament which divided the waters which were under the firmament from the waters which were above the firmament, and it was so.
That is that is some Marshall Mathers ass spoiler right there.
There are two words that are translated here by the 1611 translators that need a little more reach. Rakia actually means an extended surface, expanse. It's labeled firmament in our English translation. It's an expanse, meaning it is a flat as a base or support. The Hebrew word signifies like a sheet spread or a curtain drawn out, is the thought. The other word there, that's mayim, which is translated waters, recognize that it's a term as close as they could get to suggesting fluids. Transitory things, fluids. I'm going to suggest plasmas. That term was invented when we discovered what plasmas were. It also can mean danger or violence. It implies motion, if you will. So let me take a liberty here and use modern terms and translate those things. And God said, let there be an expanse in the midst of the plasmas, and let divide the plasmas from the plasmas. And God made the expanse and divided the plasmas which were under the expanse from the plasmas which were above the expanse, and it was so. So I suggest that as a possibility. God challenges Job. He says, can thou bind the sweet influences of the Pleiades or loose the bands of Orion? These are constellations that are tied together not by gravity, by electromagnetism. The seven sisters, the Pleiades, are a group of stars, but they're physically, they look
Bound
like
together
actually
by electromagnetism. What do you mean?
I thought they were just gravitationally locked.
I mean, they are definitely gravitationally bound. He's asserting, as a result of this new cosmology, that they are also electrically bound.
Okay.
But it is sufficient to describe them as being gravitationally bound. That is normally how I make the Pleiades argument. Which, by the way, the thing that he doesn't say here is that the two constellations that he calls out, Orion's belt and the Pleiades cluster, they are the only two constellations that are not optical illusions. They are actually gravitationally bound. And the Bible seems to guess at that and gets that correct, which naming the only two out of all of the stars, that's pretty if it's a guess, it's a hell of a guess. Twice in a row.
Orion, Pleiades, huh?
I forget. Are the Pleiades? Is Pleiades the Seven Sisters? Is that what that is?
Yes, Pleiades is the Seven Sisters.
Okay. Which became six.
Right.
Do you know about that?
Mm-hmm.
You don't know about the Seven Sisters that became six? That's like the oldest story ever made.
No.
Okay. That's the oldest story ever that we have. It's a story that's like 100 to 120,000 years old or whatever. Cool. It's about how in the seven stars of the Pleiades there used to be seven, and then over the course of about 120 to 100,000 years, one of them faded, and people were saying like, "Oh, there used to be seven, but now there's six," and then they make up a story about why it's gone.
And we can see it now with our modern telescopes that there's still something there, but it is not visible to the eye.
Yeah.
Okay. Cool.
Yeah, dude, isn't Sci Wars so cool?
Yes.
together not by gravity, by electromagnetism. The seven sisters, the Pleiades, are a group of stars, but they're physically, they look like they're together. They're actually quite distant between them. What's binding them together is the equations of James Clerk Maxwell, not the equations of Sir Isaac Newton. The boundaries of reality. We've gone a quick glimpse here, talk about size to the right. We've talked a little bit about the macrocosm, that it's finite, and that's led to all kinds of conjectures that need to be repaired in both astronomy and astrophysics. On the small side, the microcosm, we've talked about the indivisible units, the quantum physics, and subatomic particles. There is a concept that ties this all together. Because if we take a look at the metacosm, we know that we're in a digital simulation. We talked about that. Our universe is but a shadow of a larger reality, praise God. But what ties us together in the microcosm, we've been talking about the 0-point energy, right? And what ties that together to the macrocosm are the plasmas. And so we really close the loop, if you will, if you follow me here.
Can I just point out how funny it is that Tarbuck's been backing up. So Chucky here, he's talking about God with plasma and stuff, right? Old Bucky here is talking about the science side of it. Mm-hmm. And I'm over here just like, yeah, remember this thing that I wrote? Mm-hmm. So we're all just talking about our different religions.
Yeah, I'm over here like, dude, the sun's so fucking cool. The sun's like so big, you can't even think about how big it is.
You know,
that's my religion. Unironically,
I encourage you to get a book by Donald E. Scott. It's not only it's an excellent tutoring device because he's an outstanding communicator and he makes this whole subject very direct and illuminating without talking down to you. The Electric Sky, a challenge in this environment. Much of what I've drawn here is drawn from his book. It's readily available. A more technical term, maybe more greater historic interest, is perhaps physics of the plasma universe. But if you Google any of these guys on the internet, you'll get a plethora of resources and references that will take you through this. Now, we put what you've experienced here this evening is the boundaries of what we call the boundaries of reality series. We did a thing called Beyond Time and Space many years ago, talking about the impact of Einstein's theory of relativity and the nature of time and the nature of space and hyperspaces. We've just republished that, freshened it up, and put it out as a DVD for those that are interested. Another one that we did started 14 years ago, Beyond Coincidence, the evidence of deliberate design, the anthropic.
Are we done?
Yeah, this is basically the bibliography section, as far as I understand it.
Okay. Cool.
Yeah. If really the thing that I wanted to get across and start discussing with you guys from this video is this, like, what if the thing that holds galaxies together is not gravity, but is actually electromagnetism, and it is loops of plasma exerting electrical force upon stars, which themselves are plasma by majority and ionized things, and can be swung about by that force.
Ionized things.
Crawling creatures.
Yeah, you know, there's a familiar pattern in the language that I use.
Yeah, it's called the Moses style. He wrote
Does
that.
anyone call it that? I didn't know.
He wrote that. I don't know.
He did write that.
The first, 8 books?
At least the first 5, and I forget beyond that.
And he wrote all this?
He penned them. They were oral tradition. Like a lot of the older stuff, like Genesis, was oral tradition up to that point.
Good for him.
Yeah, what a cool guy. I like, and you see this like plasma structure in the large scale intergalactic filaments.
Mm-hmm.
Can't wait to send this recording to my brother.
It's fractal. There's a fractal shape to these things.
Right. Similarity at different scales, yes.
Unlike water.
That's a different kind of fractal. Unless you're talking about laminar flow, in which case I agree with you.
I think I am.
All right. I have to get up in 5 hours.
Cool.
Okay.
I'm driving Vamp back and forth to a doctor in like a town that's like an hour away. I'm probably going to like snooze on the way in, chill in the waiting room, and then when they're coming out and like hopped down on anesthesia, just sort of shuffle them into the car and come back home.